Okay, I think I'm recording already. Okay, let's begin. Okay, so we start with 2022 prelim first. Okay, so I will just scroll. You all got which one you want to ask? You all just stop me lah. Okay.
I need question 15.
Question
15, 1-5.
15. Anyone else has any question before 15?
Sorry, what paper is this again?
2022 O level, right?
Oh, okay.
Yeah, I'll just move to 15 first. You'll just ask if you all have questions, okay? 15. Okay, a force of 80 newtons acting on a stationary object. The object start to move a constant acceleration. What is the work done in 5 seconds? Wow. Okay, this one is quite a bit of formula. So work done, okay, the formula for work done is, no, sorry, not F. Okay, work done is force times distance traveled in direction of force lah. Okay, we already know that the force is 80. So what I need to find out is the distance traveled, right? Okay, so in this case, acceleration is 0.2. So this question will require you to apply a bit of your understanding of speed time graph. Okay, so if you know the speed, time, constant acceleration means it will be a constant gradient. The time is 5 seconds. The acceleration is 0.2 meter per second square. This means that every second, the velocity will increase by 0.2. So if 1 second increase by 0.2, 5 seconds, the velocity will now become 1. Okay, this is meter per second. These seconds. Okay, so if we know that at 5 seconds, the velocity have increased to 1, what is the distance traveled during this period of time using the speed time graph? It will be the area under this lah. Okay, so the distance traveled will be half times 5 times 1, which is 2.5 meters. So this 2.5 meters is the distance. We know the force is 80. 80 times 2.5, that will give 200. Am I right? Is that the correct answer?
The answer put D.
B, right? 200, right?
No, D. The answer put D though.
Answer put D, 800.
Nah, it was B, bro. It's B. Trust me. It's B.
It's B, right?
Trust.
Okay. I just went to check the.
I mark it is B.
It's B, okay.
Richard, this is the O level 2022, right?
No,
Bro, this
this
prelim.
Oh,
prelim.
my bad. Sorry, my bad. Sorry,
Hey, I
so
talked for so long, then you
Hey,
realize.
Mr. Wong.
Yes.
Sorry, Joel, can you explain again where you get the 1 meter per second, the 5 second from?
Because the acceleration is 0.2 meter per second square. So means every second it will the velocity will increase by 0.2. So if 1 second increase by 0.2, 5 seconds it will become 1.
Also, like go by proportion.
If you want it by formula, it will be A equals to V minus U over T. Correct? That's the formula, right? So my acceleration is 0.2. The velocity is what I'm trying to find. Initial is 0. Time is 5. So V is just equals to 5 times 0.2, which is also 1 lah.
Oh, then you just find area under. Oh, okay. Calculate work done. Okay, thank you, Mr. Wong.
No problem, okay? So, yeah. Does this make sense to everyone? Can I?
Yeah.
So, even though it's just 1 mark, actually the amount of it ties in a few understanding. Yeah. Okay, next question. Anybody?
I need 16 and 21.
Okay, I move on. Anyone need any question before 15? Okay, for those who have just joined, we are now at 2022 prelim. Okay, so if you have questions, you can just ask. Yeah. Okay. Okay, no one say anything. I'll move on to 16 first. Okay. So 16. A force of 4,000 Newton is to lift the hull of a crane at a steady velocity. Okay, the crane is used to lift a load of mass 400 kg at a velocity of 0.5 meter per second. Take G as 10 Newton per kg. How much of the power divided by motor is used in lifting the hook and the load? Power divided by motor used in lifting the hook and the load. Wow, okay. So power is energy over time. Okay. So in this case, we are looking at, okay, first, 400 newtons, 400 kg, 4,000 newtons. Velocity is 0.5. Okay. Let me bring in some stuff. Okay, in this case, right, the work done, the gain in energy that we are looking at over here is GPE, correct? So GPE, it will be mgh. Okay, and this h and this t comes together to give you velocity. Okay, so okay, first there's more people coming in. Velocity 0.5. So m is 400. Okay, first this one I was doing for the first time, so not very sure. So 400 times 10 times 0.5. 400 times 10 0.5, that is 2,000. Oh, then the answer is B, lor. 2 kilowatts. Correct. Yeah, 16 is B. Yeah. Esther can understand, or the rest of you, they all see how.
Yeah, can.
Yeah. So the main catch over here is the velocity actually is the height per unit time. So it's moving at 0.5 meter per second. So yeah, with that we get power. Okay. And then after 16, you want which question again? Sorry. 20, 21.
21.
21.
Yeah, because I did my calculation, I still got it wrong, so I'm like really confused.
Okay. For the rest who just came in, we are now at prelim 2022. If you have questions that you're not sure from prelim 2022, you can just ask, okay? Yeah. Okay, the diagram shows the length of mercury thread 0, 100, and x. What's the value of x? So 0 is 2, 100 is 17. Then you want to find x, which is at 8. So this one, if you want to go by formula, there's the formula way. If you want to go by formula just by conceptual understanding, okay, I'll just elaborate from there. This is 15 cm. So 15 cm represents 100 degrees Celsius. Because from 15 cm is 0 to 100. Right? So 100 degrees Celsius. X over here is 6 cm. Okay, so all you need to do is just 6 over 15 times 100. 40. Is the answer B? Yeah, it's B. Okay. Esther, does it make sense to you?
Yeah, I was just careless.
Yeah, okay. 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 Anyone else have any questions from 2022?
Sure.
Can.
24.
Zheng Xiang 24.
Yeah,
Zane,
23 also.
Zane 123. So I go 23 first and I go 24, okay?
Okay.
Yeah.
Okay, the diagram below shows a mirror, MN. A ray of light strikes is an angle incidence 40. The mirror turns 30 degrees to this. So this is, say, what is the new angle of reflection? So now if it turns by 30, my new one, okay, I draw at the side, and my normal is like that. Okay. Basically, my angle of reflection, the new angle of reflection, is also the new angle of incidence. Correct? So if my new angle of incidence, how do I find this angle? Initially, it is 40 degrees from the normal. So now if this whole mirror tilted by 30, my normal also tilted by 30. So my normal tilted by 30, then plus the original 40. Now my angle of incidence will be 70. So my angle of reflection will also be 70. So the answer should be C. Okay, Zane, can get it?
Yeah, thank you.
Okay. Next, 24. Okay, Zheng Xiang, okay, come. When an object is placed 15 cm in front of the convex lens, the image form is 30 cm behind the lens as shown. How will the size of image and the image distance change when an object is moved 5 cm further away from the lens? So when it moves away, the size of the image. Okay, so this one, I bring out the notes. You all learn lenses last year. Last year, okay, someone is coming in. Okay, last year you all learned about lenses. Okay, so we learned about how the object initially in front of the focal point, then at focal point, then as it moves further, okay, and further, and further. What do you notice is initially, okay, so for this question, they will tell that the image is formed on the other side and it is bigger, okay, as compared to this one, when it's in front of the focal length, the image is on the same side, is bigger. But so we have something like this, the projector. It's not photocopier, it's not camera or eye. Because camera or eye, the image is smaller. So just now the question already tell you that it is, the image is bigger. So now we're going to move backwards. We're going to move backwards means it's going to move towards here. So one thing you realize that when you move backwards, so from here to here, how is the image size changing? from bigger, from magnified, to become same size, to become diminished. So as your object moves further away from the lens, the image gets smaller. What about the image distance? Initially, my image distance is more than 2f. Then my image distance becomes at 2f. Then my image distance becomes less than 2f. So one thing you can tell is the image distance is getting shorter. Okay, so from this comparison, I think it's quite clear that as the object moves away from the lens, okay, when the object moves further and further away from the lens, the image becomes smaller and the image distance also becomes smaller. Okay, so going back to the question, size of image decrease, image distance decrease. So the answer should be A. Okay, was that quite clear?
Thanks. Yeah, I got it. I think that time when I did it, it's just like I wasn't clear enough about light.
Okay, no worries.
Okay, so basically in summary, it's just when the object moves to the left, the image becomes smaller. Object moves closer to the lens, image becomes bigger.
Right.
Okay, thank you, Ja.
Sure, can go through 29 also.
Can.
Thank you.
Wait, so also 33 after 29.
No, I thought we went through 23 already.
No, 33.
Oh, you want 33 lah. Okay, can.
I need 26.
26. Okay, we go 26 first. 26,
Okay.
then 29, then 33, correct? Okay. Okay, ultrasonic sound wave, 33 kilohertz. We say echo 100 milliseconds later with the speed of sound as 330. Distance between the bat and the object reflecting the echo. So, imagine that I have a bat, I have the object, the sound travel to and back. Okay, so the distance traveled is equals to speed times time. But the distance between these will be the speed times time divided by 2. Correct? Because it goes there, come back. So this distance will be whatever distance that the speed and the time takes, okay, and it comes back and then it's divided by 2. So they tell that the speed is 330. Time is 100 milliseconds. Milli is 10 to the power negative 3 divided by 2. Okay, so I key into my calculator 330 times 100 times 10 to the power of negative 3 to 16.5. Is there such answer? A. Is that the correct answer? 26. Yeah, it's A, correct. Okay.
Mr. Wong, I have a question.
Yes, Royston.
So okay, so if do you have to memorize like the speed of sound in like the different mediums? Like for in air it's like 330 meter per second. For in water it's 1,500 meter per second, and if it's in steel it's 5,000 meter per second. Must you memorize that?
You're not required to memorize, but it's good to know that it's roughly that amount. So when you see it, you don't feel like yeah, as in you get a sensing lah. Get a sensing.
Oh, okay.
Yeah.
Okay, thank you.
But they don't expect you to memorize. But speed of light, yes, you are expected to know that.
It's
Speed of
3.0
light.
times 10 to the power of 8.
Correct. Yeah.
Okay, thank you.
So because they don't require you to memorize, you look at the question, sometimes the question speed of sound, they may get you to use as 300 meter per second. Sometimes they might use 330 meter per second. So this one depends on the question. So you look at the question carefully. Okay? Esther, okay?
So this question, you don't have to use the frequency or anything.
Yeah, don't need to use a frequency. Just throw it in to mess people up who are not sure what.
Okay, thank
Yeah.
you.
Wait, you apply the concept of like that like the you look like you're trying to find the depth of the sea that formula, right?
It's the
Like
same
the
thing. Right.
cause I think I manipulated the that formula, but you started with distance, but my one, like instead of d there, right, is my speed. So
Oh,
like, is it? Wait, uh, wait, never mind. It's the same thing.
yeah, it's the same thing, right? Because when we learn
Yeah.
echo, actually it's more of the concept of echo lah. Okay, the part about how the sound travels and bounce back. Yeah. So usually, yeah, one of the common questions we like to ask is when it bounce off the seabed and kind of stuff. Yeah.
Okay.
Mr. Wong, what is the seabed formula? Like the depth of the sea formula, what's that?
There's no depth of the sea formula, but we are looking at echo in terms of the ship send the sound to the seabed, bounces back, then it's the same thing. Oh, this one. Oh.
Or distance divided by 2.
Yeah.
Okay, thank you.
Okay. So I move to 29. Okay, a 25 ohm resistor is connected across a potential difference of 8 volts. The charge of an electron is that how many electrons will flow past the resistor in 4 seconds? So electrons flowing past in 4 seconds. So first we need to know the current lah. Okay, because over here they mention about electrons being charged, correct? And they also mention about 4 seconds. So the formula that comes in will be that charge is equals to current times time, right? Q equals to IT or I equals to Q over T. Okay, so we know that time we are looking at is 4 seconds. We need to know what is the current. I know that 25 ohm resistor connected across PD of 8 volts. So from here, I use my formula V equals to IR. Okay, so I equals to V over R. V is 8, R is 25. Okay, then over here, I know that my charge will be 8 over 25 times 4 seconds. Right, so my current times time. So this will be the amount of charge. This amount of charge, each electron is 1.6 times 10 to the power 19. I take this divided by 1.6 times 10 to the power 19. I'll know how many electrons pass by. Okay, so now we put it into the calculator. 8 over 25 times 4, 1.28. Okay, so in 4 seconds, the amount of charge it passed through is 1.28 coulombs. But each electron is 1.6 times 10 to the power 19. Okay, so I will take this 1.28 divided by 1.6 times 10 to the power of negative 19. I have 8 to the power of 18. So my answer should be B. Is the correct answer B? Yeah, B. Okay.
Thank you, Joe.
Okay. Did someone say 30?
31.
31. So no one say 30, Okay. Which is the graph of current against PD for a semiconductor diode?
What's that?
Semiconductor diode is this thing that only allows current to flow in one direction, but not the other. Do you have that in your notes or textbook?
So what chapter is that supposed to be in?
I think
So
DC
is this the
circuits.
thing? Is this the thing that follows Ohm's law or something?
If it follows Ohm's law, it will be this. C is the Ohm's law. This one, No, wait first. Does it follow if is it Ohm's law D? So Ohm's law is your V against R. Okay, but wait first. One by one, I answer Damik's question about semiconductor diode. So basically,
Mr.
yeah,
what does
yeah.
Ohm's law state?
One by one. So it's a device that conducts current only in one direction. Okay, so in that case, it will already help you eliminate two of the answers here. Okay, which is C will be out, D will be out, because here in C, okay, both directions, you notice that there's current and there's voltage. Okay, over here we take positive and negative as different directions. Okay, so means it should be only able to work in one of the orientation. Okay, meaning one side can have something, the other side will not have anything. Okay, then Ohm's law. What is Ohm's law? Okay. This Ohm's law because IR. Okay, so basically, in Ohm's law, if something obeys Ohm's law, the potential and the current will be directly proportional to each other. Yeah. So that also means that the resistance is constant. But in real life, a lot of devices, they may not follow Ohm's law, meaning the resistance may not be constant, then the V and the I is not directly proportional. But most of the devices we use in secondary school and discuss, we assume that they all obey Ohm's law so that we can just straight use this formula to calculate. It'll be quite straightforward. Okay. So coming back to here, I already know that C and D doesn't work because semiconductor diode only conduct electricity in one direction. So the answer over here should be, okay, should be A, because you see, this axis is potential difference, meaning when our potential difference increases, I have a current. Then my potential difference increase in the other direction. In this case, it shows that I like almost have no current. This graph, why cannot? Because when my potential difference increase in this direction, my current suddenly spike up to a lot. So it should be no current lah. So it shouldn't be spiking at all. So this one is no. So the answer should be A. Okay. So there's a very small current that is flowing through this, but it's as good as no current lah. Okay.
Okay, thank you, Mr. Ong.
So after 31, is it 33? Did someone say 33 just now? Or is 31 the last one?
I think 33 Joshua said.
Oh, Joshua said, okay, can. The diagram shows four electric kettles plugged into a four-way adapter. Extension lead connects to the adapter to the mains plug. Okay, if the main plugs work without a fuse, why is this use of the adapter dangerous? The water in the kettles will overheat. The heating elements of the kettle will overheat. The leads connecting the kettles to the adapter will overheat. The extension lead connecting the adapter to the main plugs will overheat. The answer is D. Okay, because water, you are heating the water lah. There's no such thing as the water overheating lah. So this one is quite a useless answer. Heating elements overheat. Heating element is supposed to heat up your water lah. So not exactly what we are concerned about. So the main thing is about the leads connecting the kettles to the adapter, meaning this one. Leads connecting kettle to adapter. On their own individually, they will just draw a standard amount of current. Okay, so based on, all your devices, they always come with, if they are 240 volts, what is the power? So based on that, you use P equals to VI you know the power, you know that in Singapore, our mains are about 240 volts. We know the current that it draws. Individually, the current that it draws, there should be no issue. But what happens is when all of them all plugs together to here, my extension lead is drawing out a lot of current from the mains. Okay, so this extension lead will overheat because it's drawing out too much current, then it might cause fire. Okay, so at here, no issue. The issue comes when at this part, when actually there's a very large current flow, when you plug too many to it. Okay,
And Mr. Wong, so like the green part is also an issue, but it's not as relevant as the yellow
the
extension
green
there.
part is not exactly the issue. Because the green part is
Oh.
they just draw a standard current based on the power rating.
Oh, it's
kettle.
standard. Oh, okay,
Yeah.
okay.
Because
Thank you.
each kettle, like each electronic device, you can see, they always tell you what is the watts and what's the voltage. So for Singapore, our voltage is about 200, 240, the kind of voltage lah. So then based on the power, you know that Singapore is about 200 to 240 volts. You can know that there's a standard current it should draw if the device is operating normally. So as long as they are all operating normally, this green color one should not be an issue. But then when all these add up to this yellow one, because this yellow one need to draw enough to support all these four. So you draw a much larger current, it can overheat. Yeah.
Thank you, Mr. Wong.
Okay. Any other question?
Sure, can we go back to question 16?
Can. 16 I explained before already.
Yeah. But I wasn't here. I was just here for the last
Then you
part.
go and watch
I
the recording.
understand
later.
the 2000 watts part, but they also said 4000 newtons is needed to lift the hook. Isn't the 2000 watts only for the load?
Yeah, the 2000 kilowatts is for the load, but as in this 4000 Newton is already lifting the, as in this 4000 Newtons, lifting this 400 kg, isn't, as in to lift this, you need 4000 Newtons, man. Right?
But it still needs the 4000 newtons of force every second, right? So shouldn't that contribute to the power also?
Mm, 4000, let me see. Steady velocity.
Hey, Mr. Wang, can you just follow the formula like power equals to force times velocity?
We don't really teach that as a formula lah. You learn that
Oh.
from tuition, is it?
Yeah.
Force times velocity, yeah. But basically, if you notice over here, it just comes from this law, force times velocity. So, but Kedrick is asking why we only look at this 4000 and not this 4000, correct?
Isn't
Yeah.
it because they cancel out each other? Because there's no net force.
But they're both
What?
upwards, what?
No, like 4000 is needed to lift, but then the 4000 is already included in the equation, what?
Yeah, but they said used in lifting the hook and the load. The hook needs 4000 to hold it out. So 4000 per second, no?
But the hook, the hook.
What?
The hook is at the bottom, right? Oh yeah.
Yeah, but it's not part of the 400 kg. The hook itself needs 4000 already, on top of the 2000 newtons of force for the weight, the load.
At a steady velocity.
Meaning
Maybe
that
because the weight
the
of the
gravitational
thing
force.
is
This one, if need, I also need to go and check with the setter. What does this 4000 Newton goes to? But yeah, but from the answer seems like if the answer is B, then most likely it's just like that. But why this 4000 is not included? I'm also not very sure. Yeah,
But by right should be included, right?
I think there's a reason why it's not included, which I also I need to go and check the setter for this question. Yeah.
Okay, can. Thank you.
Okay. Someone asking something? No? Okay, can. Okay, then yeah, 2022, any other questions?
Rachel, can you like explain 36?
Can. Just let me
So,
note down this question.
Mr. Wong,
Yes,
after 36, is it okay if you could do 40?
can.
Thank you.
36. Okay, correct? This one, right? Okay. A permanent magnet can be demagnetized by using a solenoid and switching the current on and off. Which diagram shows the most effective method of producing demagnetization? Oh, this one, Joshua got asked me this question before. Okay. So to do demagnetization, I think one thing you know is we use alternating current. So alternating current will be C or D. Okay, when you use a battery, what you get is just a direct current. Okay, so this symbol means alternating current. So C and D, these two are alternating current. So the answer must be either one. So the difference between C and D is that this one you just leave it there. This one you pull out when it is still moving. So to demagnetize, you should pull it out while it is still switching the direction. Yeah. So the answer is
Wait, what? Like we're supposed to know that too. Like the methods of demagnetization, we're supposed to know that.
I thought in the slides got.
Oh, really?
You see, no. Wrong. Okay, I show you all the slides. This what chapter? This is magnetism. There. We draw alternating. Okay. Yeah.
Okay, thanks.
Okay. So after 36, Esther wants 40, right? Okay, a lamp is connected to the secondary coil of a transformer by long leads which have resistance of 2.5 ohms. As shown in the diagram, the resistance is shown in a single resistor. Okay. If the current flowing through the lamp is 2 ampere, what is the current in the primary coil and voltage across the lamp? So here is 2 ampere. They ask you for the current here and they ask you for the current here and the voltage here. Correct? So the voltage here, we can make use of our understanding that the turns ratio, when the number of turns decreases, the voltage also decreases proportionally. So we know that the formula is the N. So okay, with us, if we want to find V, so I'll put the formula in a way that is suitable for us. Vs over Vp equals to Ns over Np. Okay, so basically the ratio in terms of the turns and the ratio in terms of the voltage are the same. Okay, so I want to find Vs. This will be equals to Ns over Np times Vp. So the number of turns in the secondary is 80, primary is 1006, voltage is 240. So I key into calculator 80, 1006, 240. So it's 12. So the voltage across the lamp is 12. Okay. So the voltage across the lamp is 12. Then the current V equals to IR. I equals to V over R. 12 divided by 2.5. Is it correct? No. No, that is not the resistance of the lamp. First, let me see. Do I know the resistance of the lamp? No. I want the current in the primary coil. What I'm calculating? Sorry. Okay, first. To know the current in the primary coil, I know the voltage here. How do I know the current? I is 2, T20. Oh, okay. So you know this. You also know that we assume that this is a ideal transformer. The ideal transformer, there's no power loss. So so P in the primary will be equals to P in the secondary. So VP IP equals to VS IS. So we know that VS over VP equals to IP over IS. Linking it to here, we know that IP over IS equals to NS over NP. Okay, I think if you have memorized the formula, you will remember this from scratch lah, but you know I usually tend to derive my formulas based on understanding. So using this understanding, I know that this is like that. So then with this, now I can solve. I want IP, it will be equals to NS over NP times IS. So secondary is, is my formula correct? Because let me check. Am I doing it right? Yeah, should be correct. So NS is 80. MP is 1006. Current is 2. Okay. How come like the answer be wrong? The current,
Isn't it 0.1?
no. What is the correct answer for this question?
Isn't it 40 what?
The answer is B, what?
They give you 2 current for the across the lamp what? So it's
okay,
2 times 1600 divided by 80.
Yeah, 80 over times 2 lah, which is 0.1 lah,
No,
correct?
it's inverse what, Cher?
Sorry, what is inverse?
Isn't it 2 times 1600 divided by 80?
2 times 1600 divided by 80.
80 over 1600 is for current, for voltage. Current is inverse, isn't it?
$80 over 1006 is for current.
No,
Current
it's
is
for
in inverse. As in, I think 0.1 is correct, right? Maybe my voltage calculation is wrong. Okay, let me check. Is this correct? I know voltage is 12. 12.
Is it because of like the resistance of the lamps?
Yes, feeling we need to make use of that. Let me see. How do we get to there? if I know this is 12 volts, okay, so but anyway, this part can follow, right? The 0.1 ampere. I think this one should be correct. I think this one I still need to account for the resistance of the LED. Okay, 12 volts is across the whole thing. So if 12 volts is across the whole thing, the current flowing through here is 2 ampere. Then the resistance will be, oh, okay, because okay, so but this part, everyone okay, the 0.1 ampere, this one should be okay, right? Okay, but the voltage across the lamp, 12 volts is the voltage across the whole thing, the lamp plus the resistance of the lamp. So, to know the resistance of the whole thing, V over I, V is 12, current is 2, the whole thing will have a resistance of 6 ohms. If this whole thing is 6 ohms, this will be 3.5 ohms. Correct? If this is 3.5 ohms, the lamp voltage V equals to IR, so 2 times 3.5 is 7. Do you all follow? Okay, so this one, the calculation's not so straightforward. Okay, I repeat the whole thing again. First, we start with the primary coil current, which is 0.1. How I know that 0.1? Okay, I know the formula is IP over IS equals to NS over MP. Basically, when the number of coils decreases, the current will increase, and vice versa. So with that, I multiply my I over, I sub in the values, 880 over 1006 times 2. My current is 0.1 ampere. Okay, means that, yes, the current will from smaller becomes bigger because my voltage from bigger becomes smaller. That should make sense now, because the power, we assume that the power before and after is the same. Okay, so the power before and after is the same. When my V decreases, my I will increase. So my V from 240 drop to 12 volts, my current from 0.1 increased to 2. Okay, so my voltage dropped by 20 times, my current increased by 20 times. So then how come my voltage across the lamp is not 12? 12 volt is the voltage across the whole thing over here. But the resistance of the LEDs, okay, is about 2.5 ohms. So this means that the voltage across the lamp is not 12. The voltage across the whole thing is 12. So how do I know the voltage of the lamp? Okay, I go back to do some calculations. First, I go and calculate what is the total resistance here. So I know that the total resistance here will be equals to 12 volts divided by the current, which is 2 ampere. I know that it's 6 ohms. So this means that the resistance of the LED plus the lamp, total resistance is 6 ohms. Total resistance is 6 ohms, this is 2.5 ohms. The lamp will be 3.5 ohms. If I know the lamp is 3.5 ohms and 2 ampere is passing through it, V equals to IR, I is 2, R is 3.5. The voltage across the lamp is 7 volts. This is also another way to look at this is through your potential divider way, but I think like that also can, yeah. Okay.
Mr. Wong, so
yeah.
Mr. Wong, so IP over IS equals to VS over VP.
IP over IS equals to VS over VP, yes.
Then IP over IS equals to NS over NP.
Correct, because VS over VP is equals to NS over NP.
Oh. Yeah. In like normal like paper 2 questions, right? And they ask us to have like this kind of relation of the current and the number of coils, right? Must we show these working, or can we just write IP over IS equals to NS over NP?
Oh yeah, can. You can straight away show this. As in, because
okay.
I'm someone who often don't go and memorize this, I go by deriving lah. So if you notice from the start, I go by understanding. Like even this formula was, I go and based on my understanding, I know that when the number of coils drop, my voltage drop proportionally. So I came out with this. Then this one is based on the understanding that I assume that the power input is equals to the power output. So the power in primary equals to power in secondary. Then I came out with P is equals to VI. Then I come out with this. So this is how I do it without memorizing formula, but just from understanding. But if you memorize the formula, you can straight away use it directly. Yeah.
Thank you, so.
Okay.
Actually, can you go through 39? Number of this?
The diagram shows the forces of F acting on two wires carrying current out of the pitch. Which diagram is correct? Out of the pitch. So using your Fleming's, or not Fleming's, using a right-hand grip rule, if the current is coming out of the pitch with a dot, okay, you use your thumb to point towards you, your fingers will go in this direction, right? So your finger goes in this direction. Okay, this is correct, this is correct, this is correct, this is correct. The other two are wrong. The other two, the current point in the wrong direction already. So now it's either A or B. So this one you have to go back to understanding like that. You know, if the current are flowing in the same direction, they will attract each other. So the answer should be B. If they are flowing in opposite direction, they will repel each other.
Then, so this current magnetic relation is standard lah. So if
Yeah.
same direction, attract. Opposing direction, repel.
Which chapter is this? Is it current for magnetic? I think it's 21.
Isn't it same direction repel?
No, it's same direction, attract one.
Legit?
Yeah.
Yeah, I show you all the notes, then we will all know the same thing, okay? Is it somewhere here? Oh no, because let me try to find. Is this the correct chapter for those who offhand can remember?
I think so.
There. Yeah. If they are opposite currents, conductors carrying current opposite direction, they repel. Conductors carrying current is the same direction attract.
Oh shit, my bad.
Okay. So for this,
Thank you, Mr. Wong.
attract. Yeah. So yeah, same direction. So the answer is B. Okay. So this question tests you two things: whether you know your right-hand grip rule. The right-hand grip will tell you that the answer is A or B. Then, if you understand that the current flowing in the same direction attract, then it will be B or D lah. Okay, because these two give you attracting. Okay, but the one with both correct is B lah. So answer is B. Okay. Any other questions for 2022?
Yeah, just I'm looking through, then I saw like question 7 and 8.
Okay, a force of magnitude 24 newtons pull two boxes on level. Frictionless fall as shown. The two boxes on an inextensible road, negligible mass, both move with the same acceleration. What is the tension between the two boxes? I think this question we did similar in the workbook before. Okay, so how you can look at this? A few ways. You know that the tension over here are equal on both sides. Okay, meaning it pulls it at a certain tension, means this also pulls this back at a certain tension lah. So if you want, you can look at this as two separate objects. Okay, we have an 8 kg object moving with a certain amount of tension. You have a 4 kg object experiencing 24 newtons here, experiencing a tension backwards. And both of them are moving together, means they have the same acceleration. So at the same acceleration, you know that for each of them, the F equals to ma should be the same. The A should be the same. Okay. So over here, my F is 24 minus T equals to 4 kg A. Over here, my F is just T 8A. Correct? Okay, so from here, I know that T is equals to 8A lah. So, okay, and then now like that, it seems like I can do some substitution. I can either replace my A with T or my T with A. So since I want to find T, then I will get rid of my A lah. So T equals to 8A, so then 4A will be equals to half T lor. Correct? So 24 minus T equals to 0.5 T. Because T equals to 8A, then 4A equals to half a T lah. So then I just rearrange this. 1.5 T equals to 24. So T, 24 divided by 1.5, 16. Is the answer 16? Yeah, the answer is 16.
Wait, sure. So for the 4 kg box, there's two forces acting on it, which is the forward force, the forward
24
force,
newtons.
I mean to the right, yeah. And it's getting put back by the rope, so called.
Correct. The 8 kg is also getting pulling it back
It's getting
with this tension.
put to
Correct?
the right. Or then you just simultaneous equation, whatever.
Yeah, to come out with the T as 16.
The 24 minus T is the net force, right?
Correct.
Oh, okay. Get it now.
Yeah. So you know net force is MA law. So M is this, then we know that both have the same A ma. Then this T is the same thing, then I can. Yeah.
Oh yeah, they move at the same. Okay, yeah. Thanks.
Okay. Question 8. Diagram shows a van traveling on a road which condition allow the vans to move with maximum speed. Maximum speed air resistance should be the lowest lah. Then the friction, you want to move forward, then actually you want between tires and road, you want a greater friction to have more grip. Because if your friction is lesser, the wheels might spin on the spot. It's just like, you know, those athletics people, their shoes are spiked shoes. So they got more friction, they can grip onto the road better, then they can move faster. Yeah. So the answer should be
Mr. Wong, doesn't friction act as a resistive force?
yes,
Like,
friction
doesn't
acts as a resistive force, like let's say you want to brake or what, but in this case, you are looking more at you're trying to move forward, you need a grip onto the road. So actually, in this case, that's why your wheels, we have a lot of lines so that, you know, you can have a grip so that, you know, when you want to move forward, you don't move so much on the spot. Yeah. If it's too smooth, then when your wheels start to spin, then it might start to spin on the spot if there's not enough friction. Like it slips on its own. Yeah.
Then okay, I get it. I get it. Yeah, thank you.
It's just like
Thanks.
imagine if your shoes is very slippery, ask you to run, you see yourself, you might have a chance of slipping on yourself. Like you run, your legs move backwards, but because not enough grip, not enough friction, your whole leg really just move backwards and your body don't move forward, kind of stuff. Yeah.
Maybe someone have a question.
Mm.
I remember like one of the questions that we did previously, right? Where one of the wheels was actually like moving because of it was moved because of like the engine, whereas there was like one more wheel that was like following behind. Then it's like it went in two different directions.
I need to see the question.
Oh,
You can find the question you send me.
okay.
Okay. So this paper, any more questions? If not, I move to 2021. Okay, I assume no questions here. Okay. 2021. Okay, 2021. Which one do you want to ask? 2021, I think you all did better. 2022 average was 29. 2021 average is 31.2. So yeah. Okay, come in any particular question?
Question 16.
Okay, can.
Yeah,
25 also.
just we are. Can you also go through question 14 and 15?
Okay, 14, 15, 16, and 25, correct? So
I need 8, please.
You need 8, okay.
Thank you.
Hey, we start with 8, okay. First, I just circle in case I forget. So
Just 7 and 7.
What?
Okay,
7.
it was 25, right? Someone said 25. 14.
Joshua, 7 is just vectors, bro.
Okay, 7. Resultant force.
Wait. No, sorry, not 7. 6.
Oh, 6, okay.
Walao.
So
Mr. I found a question. I
not
sent in the
7.
group chat.
Sorry?
I found a question. I sent it to the group chat.
Okay. We will come to that later, Ken. Okay. Okay, 6. A student stand near the edge of a cliff. He throws the ball upwards as shown. The ball rises vertically a short distance, then falls. Air resistance is very small as the ball moves upwards. Which statement is correct? Maximum displacement covered by the ball and the ball thrown upwards is 0.8. Yeah. 0.8, right? This one is so the displacement is 0.8. Terminal velocity of the ball is at 0.4 seconds. No lah, this is not terminal velocity. This one is just it throws up. And then it's changing direction.
Then where's the
Terminal
terminal
velocity is
velocity?
sorry.
Then where is the terminal velocity?
Terminal velocity is when an object, right, is falling, right? Then the gravity is equals to the air resistance. Then when the gravitational force equals to air resistance, the resultant force is 0. So the object will just fall at a constant velocity. We call that velocity terminal velocity. Okay, but when it's thrown all the way up to the top, at the top moment, actually the ball is stationary for that split second at 0.4 seconds. There's no terminal, the velocity is 0. It's just like you throw up. So it's just like you take a ball, you throw upwards, the ball's velocity will drop. So you drop until you reach the highest point. It has the lowest velocity of 0. Then now it changes direction and comes down. So that one is not terminal velocity. That one is actually just a 0 velocity. Okay. The velocity of the ball is represented by the area between the graph and time axis. Notice a displacement time graph. The velocity is represented by the gradient. So you can see the gradient here. The gradient decreases, it gets less and less steep. So you can see the velocity is actually dropping. Then when over here is flat, 0 gradient means the velocity here is 0. So at 0.4 seconds, it's not moving. Then after that, the velocity starts to increase. So you can see it becomes steeper. And then the ball starts to fall at 0.8. No, at 0.4, then it starts to fall. So before 0.4 is going upwards. After 0.4 is going downwards. Yeah. So the answer is A. Okay, Joshua?
Yes.
Okay. Question 8. When a block of mass 2 kg is pushed with a horizontal force of 3 newtons along a horizontal flat surface, it moves at a constant speed of 1 meter per second. How will the block move when it's pushed along the same surface at a horizontal force of 7 newtons? Okay, so this, we have a surface, 2 kg. When this is 3 newtons, constant speed. Constant speed means resultant force 0. Resultant force 0 means acceleration equals 0. So that's why, constant speed means acceleration equals 0. So acceleration 0 means resultant force is 0. So resultant force 0 means if the pushing force is 3, then the friction will also be 3. Okay. So if you know that the friction is 3, now they say it push along the same surface, but now my horizontal force is 7. So now this is 7. So F equals to MA. F is 7 minus 3. M is 2. A is what you're trying to find. So 7 minus 3 is 4. 4 divided by 2 is 2 lah. So the object will move at constant acceleration of 2 meters per second squared.
Okay, thank you, Mr. Wong. I understand.
Okay. So continue on. 14. The diagram shows two mercury barometers. The right hand diagram shows a tube of larger diameter. There's a vacuum above the mercury in both tubes. Which label position shows the mercury in the right hand tube? Same or B.
So is it because of the? I remember you explained it for the paper 2, that one. Like the same idea, right?
Paper 2, that one same idea.
Like the 4 times the cross-sectional area thing.
I can't
don't know if
remember
you remember.
which question, but anyway, when it comes to mercury barometers, when you look at liquid pressure, you look at the formula of H rho G. Okay, so G is always 10. Density, in this case, if both are mercury, the density does not change. Then to get the same pressure, the height should be the same. So the answer should be B. Yeah. Okay. So the width does not matter. Okay. The height will make the difference. Okay, question 15. A manometer containing mercury still at one end. What happens to the distance h when the manometer is taken higher up the mountain? So at higher up a mountain, your atmospheric pressure will drop. This one you're supposed to know, you go higher up the mountain, the atmospheric pressure will drop. So if the atmospheric pressure drop, so because atmospheric pressure is pushing down from here. Okay, so if this pushing down is dropping, what will happen to this h? If this pushing down is dropping, then this h will also drop because some of it will start to go up. So the answer will be it decreases because atmospheric pressure decreases with height. Yeah. Okay.
Sorry, Mr. Wong. If the atmospheric pressure, the level goes up, shouldn't it increase height? Like it go up, right? So increase, no?
What increase again?
The atmospheric pressure decreases, right?
Yeah, when you go up
So
the mountain.
yeah, so the level, the mercury level will increase.
Where
go
will
up.
increase?
The mercury level representing the atmospheric pressure, it will increase. Like on the right side, it will increase, right?
So this side will go up a bit then.
Yeah, when it go up, then shouldn't the
And
atmospheric
this side will
pressure?
also drop. Then H will drop.
Yeah, then shouldn't the reason be because atmospheric pressure increases with height? Like wait, it doesn't make sense.
Yeah, the atmospheric
Yeah,
pressure
it doesn't make
decreases.
sense. Yeah, okay, yeah.
Right,
Sorry,
correct.
sorry. I
Okay.
interpret wrong.
Yeah, no worries. Okay. Okay. 16. Okay, very small pollen grain as suspended water, bright light shines from the side. When looked through a microscope, small specks of light are seen to be moving in random, jerky manner. What are the moving specks of light? B. Okay, in the first place, you can't be seeing water molecules lah. Okay, water molecules you cannot see with a microscope one. Okay, how are you going to see a water molecule? It's just so small, H2O. Okay, so it'll be pollen grains. So pollen grains in this case either hit by other pollen grains or by other water molecules. in this case, we are looking at the concept of Brownian motion actually hit by the invisible water molecules that cause the pollen grains to just move in a random jerky manner. Yeah. Okay.
Oh, okay.
Yep. Okay. Yeah, because the pollen grains hit by other pollen grains, you will not be seeing that because, as in if you remember the video for the Brownian motion, you just see the particles like just moving on its own random jerky. One pollen grain need not collide another pollen grain for it to be moving. Yeah, it will just already be moving. Okay. Okay, I move to 25. Tom peeks through a keyhole in a door and sees the reflection of the back of the door in a mirror. What is the maximum length of the door that peeping Tom can see? Peeping Tom can see the mirror is 20 cm long. So this one should be 40 cm, right? Because when he sees from here, okay, your angle of incidence will be equals to the angle of reflection. Same thing over here.
So it's 10 cm on both top and bottom. So it's 20 plus 10 plus 10.
Yeah, you can see that, but this one is not very in the center lah. If it's center, then it's 10, 10, 20, but this one is not center, so, but it will still add up to 20 because for whatever, if this is 20, then whatever amount you can add on top and bottom will just be 20 long. So the answer is D, 40.
Oh.
Yeah.
I think it kind of makes sense.
Yeah. Okay. After 25, was there anything that anyone said after 25? I think don't have yet, right? Yeah, do you all have any other questions?
Chapter 33.
33. The diagram shows two link circuits to control when a bell is switched on. The conditions are altered and only one pair of conditions used causes the bell to ring. So which condition causes the bell to ring? So this is a solenoid. So meaning the current here must be large enough. Then this switch made of iron will get attracted over. So it get attracted over, it touches this, it closes this whole thing, then the bell will ring lah. So basically you need the conditions that over here, the current is cause it to be higher lah. So this one you have your light dependent resistor and this is your thermistor. Okay. So for it to ring, for LDR, you know that the brighter it is, the lower the resistance. So the current will be higher. Okay, so in this case, we want bright light. So for thermistor, the basic default thermistor will be higher temperature, lower resistance also. So in this case, will also be high temperature. So the answer should be A. But of course, there's variations of these devices where some of them is lower temperature, as in lower temperature, lower resistance, but most of them for thermistor is higher temperature, lower resistance. Yeah. Okay.
Yes. I thought they would specify it first, so like I wasn't sure.
Usually they will specify. If they don't specify, then you treat
You
it
have to
similar
assume.
to the light that where higher temperature or brighter light will be lower resistance. Yeah.
So higher temperature, lower resistance.
Yeah.
Okay, can.
Okay. Any other questions for this paper?
Mr. Wong, can you do 24, please?
24. What is the angle of incidence and reflection? Oh, if this is a straight line, this is 80. Then straight line is 180, so this should be 100 lah. It is 100, then it should be 50, 50. Oh. So the answer will be D. Oh.
Okay, thank you.
Yeah. Okay. Any other questions? If not, we move to the O-level paper.
Sure. Question 37.
37. Yeah, I feel like you got asked me this question before. Two vertical wires pass through at right angles through a piece of card. There's a large current in each wire as shown. So this one is current into the card. So based on your right hand grip rule, you know that current into the card, you will move this way, correct? Then you have the current coming out of the card, you will move this way. Correct, based on your right hand grip rule. So the plotting compass is placed on the card. Okay, so in this case, they ask you for what's the direction. The direction we see. Okay?
Okay, and
Yeah. Okay, if don't have, we move to 2022 O-level paper, okay? The one that you all got as hard copy. Thanks, Esther, for helping me to scan this one. Okay, this one, which questions do you all have? Anybody? Or you all don't have the paper with you, so you're also not sure which one.
Sure, can you go through question 3?
Okay.
9 also.
Okay, 3 and 9. Okay, we'll go to 9 after this. Okay, an object is falling vertically near the Earth's surface at time t equals 0. The E has 25 meter per second downwards. Air resistance is negligible. What is the speed at t equals to 2? The answer says C. Because when there's no air resistance, the only force acting on the thing will be the weight. The only force acting on it is the weight. Then W equals to mg, it will accelerate at 10 meter per second square. So accelerate at 10 meter per second square. After 2 seconds, it will increase by 20. So the answer will be 45. Got it, Zain?
Yeah, thank you.
Okay. Then 9, right? Okay. A uniform rule rests on 2 supports. 3 forces X, Y, and Z on the rule. What are the sizes of the force related? So, of course, Y will be equals to X plus Z lah. This one you all should know, right? As in, you can imagine as 2 of you support one object, then the weight of this object will distribute across the 2 of you. So the answer, in Y will be the biggest. So answer will be the A or B. Then X or Z, who is bigger? So since Z is standing nearer to this, then of course Z will be supporting more lah. You just imagine you have an object, you stand nearer to the weight, the force acting on you will be bigger. Another way to look at it is you really go and apply some moments. Okay. So okay, the first one that Y is the greatest, I think you all should already know lah, that understand that Y is equals to X plus Z. If Y is not equals to X plus Z, then there will be a resultant force, then the thing will start to fly up or fly down. Correct? Because Y is equals to X plus Z, so the resultant force is 0, the object rests over there. Okay, it does not fly up or fly down. Okay. So if we take moments about X, means we can ignore X because the perpendicular distance for X will be 0. Then you have the moments, the clockwise moment of this will equals the anti-clockwise moment of this. Okay, then Another way to look at this, for this one, you take moments about Z, then you can ignore this because the perpendicular distance is here. So the moments of this will be equals to this. So over here, because the distance is, so okay, because maybe I put in some numbers so that it makes more sense for you guys. Let's call this distance as A, call this distance as B, C. So just now I say take moments about X, okay? My clockwise moment is my Y lah. So B times Y, okay, equals to A times Z, correct? When I take moments about Z, okay, so same thing, clockwise equals to anti-clockwise. Now my clockwise is X, so A times X equals to C times Y, okay? So A is the same for both, Y is the same for both, right? So if A is the same for both, Y is the same for both, then the only thing that affects is the B and the C. So you can see that over here for X, C is smaller. Over here for Z, B is bigger. So of course, Z will be a larger force law. Does that make sense for you? Or if I rearrange for you, okay, because Z is equals to B Y over A. X is equals to CY over A. So Y over A is the same. I can ignore Y over A. So who is bigger depends on B and C. So since B is bigger than C, then Z must be bigger than X. I hope like that is clearer.
Sure, can do question 10.
Okay, so 9 okay already. Okay, hydraulic press. Pressure on piston 1 is P1, pressure on piston 2 is P2, pressure at point X is P. How the P1, P2 compare with P? Pressure on P1 exerted by the oil is P1. Okay. Okay, one thing for sure is P1 will be equals to P2, correct? That's what we learn now. That the pressure on piston 1, so meaning here, because okay, yeah, so sorry. So the pressure exerting here is equals to the pressure exerting here, correct? That's what we use for a lot of our calculations. Like we assume that all the pressure will be the same. So then now the question is comparing the pressure here to the pressure at X over here. So where will be a greater pressure? So the thing about X is at a lower height. Okay. So there will be a height of oil on top of it. So the pressure at X will be also inclusive of the H rho G. So meaning the pressure here P will be larger than the pressure at P2. This is P1, this is P2. So if this is bigger than P2, then the answer should be C. Okay?
So the pressure is bigger just because it's lower down.
Yeah.
Okay, can.
Okay.
Sure, can
Any,
go
yeah.
through
Sorry,
20.
Mr. Wong.
Ah,
For the question 10, right? The height of X is lower than the question 10, je. The height of X is lower than the height of piston 2. What?
yeah, so
I don't get the height
because
thing.
it's lower, it gets an extra pressure of the oil sitting on top of it. Because like you go deeper down something, the pressure they experience will be more. It's like
So it goes by
because
depth.
there's on top of you there's water sitting on you, or like there's
Alright.
oil sitting on you. Yeah.
Thank you. Mr. Wong can go through question 2.
So, okay, just now someone was also about to ask the next question.
Bro, Tami, I explained it to you
Sorry.
already.
Well, the one I asked you is the other one.
This one?
Yeah, question 2.
Okay. A car is traveling at 10 meters per second due north. It reaches a bend. And a short time later, it travels at 10 meters per second due east. Which statement must be correct? It changes its velocity and acceleration. No?
But Mr. Wong, I understand why velocity change, but the speed is the same. Why does the acceleration change?
Acceleration is a vector also, as long as the magnitude
Eh?
or the direction changes, it also changes. Yeah.
Oh, yeah, okay, sorry. Thank you, Mr. Wong.
At JC, you go to JC, you learn there will be a term of acceleration, they call it centripetal acceleration. Basically, it's acceleration when you're just changing direction. Yeah. Okay. Then just now someone else also asking a question. Yes.
Wait, for question 2, I just have to clarify, right? So if it's traveling east, what does it mean that so the positive direction is north, like the positive is north.
In this case, they never say whether it's north, but the direction change one.
So what does that mean? Because doesn't it still travel at the same speed? I don't get it now.
So this question is actually testing on the concept of whether you understand between scalar and vector.
Okay.
So scalar is just magnitude. Vector is magnitude and direction.
Okay.
In this case, the magnitude did not change. Both are still 10, correct? So it's 10, 10. So what changes is the direction. So in this case, what are our scalar and what are our vector? Scalar is like speed, distance.
Oh wait, so it's considered like the velocity and accelerate changes because the direction changes.
Correct.
Like you don't really like need to care about like the like you just need to care about the direction basically.
At
So
your
like,
level, you just take it as the direction changes. Like I say, at JC level, there will be a kind of acceleration you'll learn. It's called centripetal acceleration. It talks about how if something just going around in a circle, how do you calculate the centripetal acceleration? It's accelerating, even though the velocity can be the same, as in the speed can be the same, but we call it accelerating, because as in centripetal acceleration is
okay, I don't think I have to worry about that yet. So
Yeah. Not now. Yeah. For
okay,
now,
I
just
get
simply take
this
it as
question. Yeah.
direction change is considered accelerate. Yeah.
Okay. Thanks.
Okay. Just now someone to ask another question.
Sure, 20, 28, 29.
Which question again? Sorry.
20, 28, 29.
20, 28, 29. Okay, I'll go 20 first. Okay. 500-watt heater is placed in a boiling liquid. 10 minutes for 360 grams of liquid to turn into a gas. All thermal energy supply is used to convert liquid into gas. What is the latent heat? So Q equals to mL. Okay, so Q in this case, we can also replace it with power times time. So the power is 500. Time is 10 minutes, so 10 times 60 seconds. Mass is 300 and, no, they want it in kg, so this will be 0.36 L. So 500 times 10 times 60 over 0.36. Eight three three. 10 to the power of 5. So answer should be D.
So is
Okay.
Q equal ml the formula?
Oh yeah, for specific latent heat is Q equals to ml.
For vaporization.
Both vaporization and fusion both use the same formula, just that it's looking at whether it's LF or LV. So in this case, it's LV lah.
Okay.
So
Thank you.
LF and LV are two different values, but the way we use it is still either Q equals to MLF or Q equals to MLV.
Okay, can. Thank you.
Okay. Then 28, is it?
Yeah.
Okay. Okay. A 12 volts car battery is connected to a lamp labeled 12 volts, 24 watts. The line shines at normal brightness for 25 hours. What is the size of charge that passes through the lamp in this time? So in this case, you know, okay, so this is Q, this is T, this is V, this is P. So P and V, okay, you can get P equals to VI. Okay, I equals to P over V. So 24 over 12, 2 amperes. So 2 amperes, Q equals to IT. I is 2. Time is 25 hours. 1 hour is 60 minutes times 60 seconds. So C. Okay.
Sure. What with that? If you change the value of like the car battery, the voltage, or like the rating of the lamp, right? Does it like affect anything? Right? Because what's the point of like saying that the car battery is 12 volts, then you say the lamp is 12 volts, like the rating?
Oh, because like I say, most electrical appliances will have a labeling of at the desired voltage it's supposed to operate at, what is the power that it uses. So this is to tell you that, okay, if you want to use this thing, use it at 12 volts. So you make sure that you connect it to a correct voltage.
So what if the car battery they give us was 6 volts?
Sorry,
Yeah.
What if they give us a car battery at 6 volts?
A car battery that's 6 volts. Then how do you
Find the watt, yeah.
Okay, this one, I think we have a question similar to this in our slides. Okay, we go to there so that you can return back to there when you're trying to revise. I think it's practical electricity, is it? So then I think this is the question that you're trying to ask now. Okay, they tell you that the bulb is rated 60 watts, 240 volts. Then they only give you 120 volts. Oh, then now how, right? Yeah, this is what we're trying to ask, right? Okay, so we have this question inside the slide already. Okay, the correct answer, solution 3. Basically, how do you go and do this calculation? Okay, first, they find out what is the resistance of the lamp. Okay, so you know that P equals to V squared over R based on there's 3 different formulas for power. P equals to VI, P equals to V squared over R, P equals to I squared times R. So in this case, I want to find what is the resistance. I know the power, I know the voltage. Okay, when it's ideal, because we know that the rating is when 240 volts, this is the power rating. So with that, I can know what is the resistance. So the resistance I calculated is 960 ohms. So you know that this 960 ohms, but then now you're only given 120 volts. Then you can find that, now my current will be a smaller current lah. As compared to, let's say, if 240 volts, my current will be double the current. So basically, when you decrease the voltage, the current that it receives will also decrease, assuming that the resistance is the same.
Is it direct proportional?
What is directly proportional to what?
The voltage to the current.
Yeah, based on constant resistance. Yeah.
Yeah, thanks.
Okay. So then we move to 29. During a lightning strike, there's a current of 300 kiloampere. When the charged cloud and the Earth for 5 milliseconds, it releases 450 megajoules of energy. What is the potential difference between the cloud and the Earth? Okay, so this one links a few formula. So potential difference, V is equals to work done per unit charge. Okay, so the energy is this, work done. Okay, then the Q, you need to get from, okay, Q equals to VI, IT, because you know Q equals to IT. So my I is this, my T is this, right? So V equals to 450 times 10 to the power 6, because it's mega, correct? Current is 300 kilo, so 10 to the power 3. Then time is 5 milliseconds, so 10 to the power negative 3. Okay, so you key this into the calculator. Six over 10 to the power 3 times 5 times 10 to the power negative 3. So 300 megavolts. So it's C, is it correct?
Wait, so isn't it 300,000 volts? So it's just 0.30
Yeah.
megavolts.
Okay. Mega, yes.
So it's
Mega is the power of 6, yes, correct. I'm so sorry. Okay, so this is 300,000 volts. So it's 300 kilovolts, or in terms of megavolts is 0.3 megavolts. Okay. But so you can see actually they like to test more than one formula combined together. Okay, so you need to be able to do that. Yeah, to really combine formulas together. So this one, there's no end to memorizing formula in the sense that, well, just now Royston was saying that, oh, isn't power equals to force times velocity. So if you just go purely by always trying to memorize this kind of formula, then it's very hard because they can combine anything for you. So you need to be able to see it for yourself. Just now, I know the mgh over t, then h over t, I see that it's velocity, so that I can apply it accordingly without being restricted to only certain formulas that I memorize. So you need to have that flexibility to understand, to combine formulas. Like for example, V equals W over IT, this kind of stuff. So I don't really teach you explicitly this, but you need to be able to combine. Yeah. Okay. Okay. Anybody next? Any other questions?
Mr. Wong, can do question 14, please?
Can. Okay, thermal energy is supplied continuously to water in a kettle to keep the water boiling. As the water boils, molecule escapes as a vapor. Okay, the water vapor above the water in a kettle is at boiling point of water. How do molecules of water in the water vapor compare with molecules in the liquid water? So, in this case, okay, they tell you the water vapor above the water in the kettle is at boiling point. So means this water vapor is at 100 degrees Celsius. Okay, then they say that the water inside is boiling. So inside is also 100 degrees Celsius. So we learned that in the kinetic particle theory, we learn about the internal KE and the internal PE. So internal KE is directly proportional to the temperature. When the temperature is the same, the average KE is the same. Okay, so yeah, in this case, since both the water are 100 degrees Celsius, the temperature is the same because the explanation we learned that is the the energy that was supplied is used to overcome the force of attraction, to boil and change the state. But the internal kinetic energy, the average internal kinetic energy, remains constant, does not change. So the temperature remains the same, correct? Okay. So then, but in terms of the force, okay, the force will be smaller, right? Because it's now a gas. It's now far apart. It can move at a faster speed, and all these kind of things. So it has overcome this force of attraction to become a gas. So now the force between them is smaller. Yeah.
Mr. Wong, there for internal potential energy, when the temperature of the liquid increases or the substance increases, the internal potential energy decreases, but the kinetic energy increases, correct?
No, the internal potential energy doesn't decreases.
Wait, so it's the same. Like when the temperature increase, what?
Yeah, the
Okay.
temperature increase.
Temperature increase, then internal potential energy just remains the same.
You can say that it remains the same, or you can say that it increase, but it will not decrease.
Why would it increase?
Because now the expanse, it moves further apart.
Yeah, then shouldn't the energy decrease?
No, it's just like I take a stone, I leave it further away from the earth, the potential energy increases.
Oh,
When you
so
move further
like,
apart, the potential energy increase.
so when for example, I boil water from liquid to gas, my internal potential energy increases.
Yeah,
because
that's where your energy goes to. So you are supplying energy to it, it's gaining energy, but the energy doesn't go to KE. KE remains the same, temperature is the same, but all the energy goes into PE. So it becomes further apart, the potential energy increases.
also my internal potential energy is the most when it's the gaseous state lah. Oh,
Because
okay,
they are
okay.
further apart. Yeah.
Okay, thank you.
Wait, Joe, what's internal potential energy again? Like
Internal potential energy
potential.
is the got to do with the force of attraction between the particles.
So if they got more potential energy, they have like the forces between each particle, between the particles are weaker.
Because there's more energy, it can move further apart.
Okay, so that's what internal potential energy is.
Yeah, you can imagine it like how gravitational potential energy, you leave the stone further away from the earth, the distance between increases, but it gains potential energy.
Okay. Yeah. Okay. Thanks.
Mr. Wong, then when the temperature increases, for example, temperature of the liquid increases, right? Then the kinetic energy will start to increase, but
Right.
not the internal energy.
Not the internal energy.
Kinetic lah. Okay, thank you.
No, as in the internal kinetic energy will increase. The internal potential energy, you can say that either you can say that it's keep it the same to make things simple, or you can say that increases because actually it's also like expanding lah. The particles are moving further apart, just that it's a bit more negligible compared to the change in the KE. Yeah. So
Okay,
most
thank
of
you.
the
I get it. So I can do 21, please.
Can.
Yeah. Isn't period the same thing as frequency? No, I mean not period the same thing as frequency. Like oh wait, never mind. I misread period as pitch. Never mind. Sorry, Jeff.
Can.
Sorry, Jeff. I misread. Sorry.
No worries.
Sure, one question.
Yes.
When using Fleming's left-hand rule and Fleming's right-hand rule, it doesn't matter if it's AC or DC generator, right? As long as you're finding the force or the current, right?
What do you mean?
Because there's one question, where they give a DC generator, but they ask you to find the rotation of the coil and find the rotation of the coil. I will use left-hand rule, right?
This feels like a question that Royston was asking recently, right? Was it?
I found it in the CHIJ paper. The answer
Actually, it's a
sheet.
different question. Like I saw the question that Kedrick showed me, like it was different. It's like
And
they
then
showed, like they
Royston told
showed.
me that for left-hand rule only can use AC. Then I was like, no, left-hand rule when finding
No,
the
left hand
force.
rule is DC, right hand rule is AC, bro.
Yeah,
You
whatever.
confused it.
Left-hand rule is just to find the force, right? It's not doesn't depend on AC or DC, right?
Okay, generally, okay,
Yeah.
when we're looking at DC motor, we are using left-hand rule. And generally, when you're looking at AC generator, we're using a right-hand rule. We also need to look very carefully and understand the context, whether left-hand rule mainly, the main thing that really talk about left-hand rule is that in that case, you must have a current flowing through a magnetic field. Then because of the current flowing through a magnetic field, there's a force. So when that is the scenario you're looking at, then there will be a left-hand rule, which in a DC motor, generally that's what's happening because you have a current flowing through a magnetic field. And when this current flows through the coil in the magnetic field, it spins. There's a resultant force to it. So usually we use left-hand rule for DC motor. Then right-hand rule is more for when you have a force pulling, like a current, a force pulling a wire through a magnetic field. Then when that happens, there's an induced EMF and an induced current. So then you use Fleming's right-hand rule. So AC generator, usually that's what's going on, where you have a coil of wire spinning and cutting through your magnetic field and generating, because of the resultant EMF, it generates a induced current. So usually we use right-hand rule for AC generator. Yeah.
Okay, but what if they show an AC generator and they give you the induced current, ask you to find the rotation? I will
Then
use
it's still
left hand,
right hand.
Still right hand?
Yeah, like I
But
say,
it's
if
to find force.
left and right hand, the concept is no. It's not about what you used to find. It's about what is the thing that is producing what. So in left hand rule is when you have a current in a magnetic field producing a force. If you are having a force pushing a wire through a magnetic field producing a current, then it'll be right hand rule.
Also, it's different concept again.
Correct. So it's not about what you are trying to find, but what is the concept involved. So whether you are producing a current or you're producing a force. You can be producing a current, but the question asks you to find a force that is producing a current. You still use right-hand rule because you are producing a current.
Okay, Ken. Thank you.
Yeah. Okay. So, yeah. Any other questions? Yeah.
30.
Can.
Thanks.
voltage current reading which readings are for a 3 volts 0.06 ampere filament lamp? Oh, this is similar to what we just discussed, right? The slide that I show you. The resistance sorry. 0.02 and 0.04. So it should be this one, right?
Wait, is it like, is the filament lamp supposed to be an ohmic conductor or not? Or is that like, wait, is that what the question is like trying to get
Oh,
you
yeah,
to understand?
yeah. Correct. You're talking about a filament lamp, and we learned that for filament lamp, they are usually non-ohmic, so they don't follow. Correct. Yeah.
Wait,
Okay,
we are
you have
supposed to
the question.
know, you're supposed to know what type of like what type of like components are non-ohmic and what conductors are what components are ohmic. Like you're supposed to know.
Generally, filament lamps are non-ohmic. Okay, let me see.
But I don't remember
what
like
slides say something like
remembering
this,
it.
right? Yeah. Okay, I
Oh.
remember this, but I don't know whether our slides got say anything in particular about this.
Then there's also I remember just now got a semiconductor diode or something. That's also a non-ohmic conductor.
Okay, wait first. Let me go to resistors, ohmic conductors, non-ohmic conductors. Oh, that's all they say. But your textbook say a bit more.
Oh, I don't check the textbook.
Because the slides usually say a bit lesser than the textbook. So,
Oh, shit.
okay, wait first.
Yeah, I think uni said like the types of graphs. I don't think they specify any like components that are not or are.
But anyway, you can
ohmic.
see over here, this one is the okay. I realize there's a lag in what you're seeing and what's on my iPad. Okay, you can see over here that this is the semiconductor diode we are talking about.
Oh, but they never say it is the semiconductor diode. They just show you the graph that they say it's a non-ohmic conductor.
Okay, let me go to the soft copy text.
I think I should note it down.
But it will be because more voltage, more friction, then temperature rise, then resistance rise, right?
What?
More voltage.
What do you say?
It's a filament, right? So it produces light and heat, right? So more voltage, more heat, more resistance, so lower current. Is it?
Because I'm downloading the textbook. Sorry, Kedrick, can you repeat yourself?
It produces light and heat, so more voltage will lead to more heat, which will lead to increased resistance, leading to a decrease in current proportional to voltage. Right? The curve would, the gradient would decrease.
Yeah.
Okay.
No, gradient will decrease.
Hmm?
Because you depends on whether you're looking at VI graph or IV graph. Is a VI graph,
I,
then
IV.
oh yeah, then it decrease. But if it's a VI graph, then the gradient will increase. So yeah.
Okay, okay.
Okay, wait first, let me load the textbook. It's under electricity. Oh, your textbook got say more stuff. You'll see.
Oh, wait. Oh, so
Non-ohmic conductors. So that filament length, you see, the IV graph, yeah, that's what Kedrick was saying lah. So the resistance actually increases.
wait, IV graph is like so-called the default one lah. Like if A increases, if V increases, A also increase. But there's also one where like the Y and X axis flip, right? Is that what?
Correct. There's
talking
also
about?
VI graph.
So what would the graph look like if it's the ohmic conductor? Now that I think about it.
Ohmic will just be straight line. Be it IV or VI, it will just be a straight line.
Oh, either way is straight line, like the positive gradient or that.
Correct.
Okay.
So IV, right, when it's an IV graph, because change in Y over change in X, so I over V. So actually the gradient is 1 over R. Because R is V over I, right?
Yeah.
But then when it's IV, the gradient will be change in Y over change in V. So that will be 1 over R. The gradient in the IV graph represents 1 over R.
Oh, so
Or R.
R will be. So either way, it'll be like the same shape. Same.
So if it is a VI graph, if the resistance is increasing, the gradient is increasing. But if the IV graph, when the resistance is increasing, the gradient will be decreasing because 1 over R.
What? Wait, can repeat?
Yeah, I repeat again. We come here to here. First, we know that V equals to IR, correct? So R is V over I.
Okay, yeah, that one, yeah, I get it.
But then when you're looking at IV graph, right? IV graph, the gradient is always change in Y over change in X. So change in I over change in V. So I over V, it will be 1 over R.
Yeah,
Because
I
V
get
over I
it,
is
right?
R, yeah.
Yeah.
Right. So if the gradient is constant, of course the R is constant, right?
Yeah.
So now if let's say over here, the gradient is decreasing. Means I over R, 1 over R is decreasing. If 1 over R is decreasing, this means that the resistance
the gradient,
increasing.
the gradient is 1 over R. So if gradient decreases, the I over R decreases.
If gradient decreases, yes, 1 over R decreases. So R is actually increasing. So the resistance is increasing.
Oh, yeah. Something to do with the fractions. Okay, I think, yeah, that makes sense.
So with that, actually, now that you all point out this, yes, I think this one in our slides we never mentioned at all. But just now, someone else also asking semiconductor diode right there. This is the graph. So when the voltage increase, the current increase, then when the voltage go in the opposite direction, means you connect it in the other direction, then it's as good as there's no current flowing. So this is how the semiconductor graph look like. Then filament length, like you point out, filament length is non-ohmic. So just now whatever calculations I did is for based on if it's ohmic, but this question is about filament length. So filament length, you can see as the voltage increases, the increase in current actually.
Oh, so you don't really need to calculate, right? Actually,
Correct.
you can just see like how the current and voltage
Correct. So
increases.
actually, this one, the correct answer should be B.
Can you
The-
go through how does
Oh,
the
okay.
negative region look like for the graph? Because I think I saw the negative region like kind of question come out for TYS.
Can negative region meaning this part?
For filament lamp also.
Okay, or TYS. Okay, can we go to TYS?
I'm not sure it's from TYS, but I saw it's from somewhere.
Yeah, sorry,
Okay.
Mr. Wong.
Yeah,
I went
but yeah.
toilet just now.
Yeah.
So is it like the filament length increase, then the current increase? Is it?
Come again, your question is?
No, so how does the filament length affect the current and voltage?
So the main thing about the concept of filament length is it's non-ohmic.
Uh-huh. That means got no resistance?
No, means that
Oh,
the
it doesn't
resistance
follow
is not
V equals
constant.
to IR.
Correct. So in this
Okay.
case, you can see that it's not a straight line, it is a curve. And in
Okay.
this case, as the voltage increases, the increase in current decreases.
Understand.
So in that case, that's why just now for this question, there's no calculation involved. Actually, all you need to do is just to see that for a filament lamp, the current, actually the increase in the current actually decreases.
Oh, okay, I understand. Thank you.
Then we go to
So I found it is
Nicholas.
TYS chapter 18, page 15.
Okay. Chapter 18.
Yes. Then is section B, question 2A.
Page what again?
Page 15. Then they ask us draw the negative region of the graph.
Oh, okay. Filament lamp and LED. So this is an IV graph. So LED will just be flat lor. You can draw flat or you can draw a little bit. Then for filament lamp, it will just be the same curvature but in the other direction. So like for example, let me try to see. Okay, it will look something like this. You know what I mean? Because it's just
So it's
connect in the
it's about the same gradient, but it's like negative region.
Correct. It will be just the
Okay,
same.
okay.
Just that now my connection connect in the other way. But for LED, when you connect in the other way, it'll just be flat because the current cannot flow in that direction. Yeah. Oh, it seems like the slides miss out some of this stuff. Like they just put like that, then just moved on. But actually, the textbook and all this got learned a bit more. In that
Mr. Wong,
case,
so must we memorize about the non-ohmic conductors, like how filament has like increasing resistance when, how filament lamp has like increasing resistance as voltage increases, and like how the
yeah,
semiconductor
you are
diode.
expected to know.
So
Okay.
is it only these two or are there more?
I think these two. Okay, I'll show you the syllabus document. Okay, means actually when we return in term 4, do get me to go through this in class with the rest, since never mentioned. DC circuits. Light emitting diodes. LED, let me see. It actually here like never say. Here says LED. But they like never say anything about filament lamp, right? Or is it here? Oh, there. Sketch and interpret the IV characteristic graphs for metallic conductor at constant temperature for filament lamp and semiconductor diode, these two. So,
Okay, thank
Is
you.
metallic conductor just the filament thing?
come in.
Metallic conductor same property as filament lamp.
Sorry, your voice is a bit muffled.
Is the metallic conductor the same gradient as the filament length?
Oh, metallic conductor.
Yeah.
Well, I say metallic conductor is just general law. Yeah, as in when the temperature increase,
okay.
the resistance increase. Yeah, so it's just the general one. Yeah. But filament lamp is semiconductor. So yeah, okay, let me write that down so that I remember when y'all come back. I need to go and point out this part that was skipped in the slides. Okay. Okay, but in the meantime, any other questions?
Mr. Wang, is it possible to go through the Chongqing paper one?
Wait, sure. Before you move on to Chongqing, can you go through question 32 and 33?
Can we first filament lamp, semiconductor diode. Okay, I will go through Aaron's question first. Then some of you actually text me some questions I haven't managed to reply. I'll go to your question first for those who text me. Then I will go to whatever new questions there are. Okay, Ken, to be fair. Okay, so 2022. First, where were we? We were here. Aaron, which questions?
32 and 33.
32 and 33, can. Okay, the circuit contains 4 emitters. The reading on A1 is 4, reading on A2 is 3, reading on the other 2. Oh, this one, this is 4, this is 3, then this must be 1 lah, because 4 comes here, it splits. This is 3, this will be 1, then consolidate back to here, here will be 4 lor. So the answer will be 1 and 4, answer is B. You understand?
Yes. I got a bit confused because I was, yeah, sorry.
Yeah, no worries. Okay, so just remember that when from 1 split into 2, then the current actually splits. But the potential difference across here and the potential difference across here will be the same. Yeah. Okay. So how to imagine this? I think the last time when I give the analogy is like maybe like you, Damik, Royston, Nicholas, you are running down around here. Now that there's 2 paths, one is narrower, one is wider. So of course more of you will go down the wider path lah. So maybe you, Nicholas and Royston, you'll run along here. Then Damik run along here. But the amount of energy you'll use will still be the same. So the voltage, the potential difference across here will be the same. And we'll jump back to here, then you'll go along here. Yeah. So current is like the number of charges. So it's like the number of all of you. Voltage is the energy per charge. So it's the amount of energy each of you use to pass through here. Okay. Okay. 33, is it?
Yes.
The diagram shows 2 circuit voltmeter readings are shown. Which row is correct? Okay. Circuit 1. Circuit 1, what do you want to say? Oh, so circuit 1 will be this or this one. Because like I said just now, voltage is energy per unit charge. So if you run out of here, you are going to use energy here and here. So you will split such that the energy you use here and here add up to give you the energy you have lah. So you can imagine the story is every time you come out from the battery, you are given some amount of energy. So let's say you are given $6. You go through here, you need to spend through or $6. So you can spend like $2 here, $4 here, then come back to here, you get 0. So the voltage, these two add up will be equals to this. Okay. Then over here, this is parallel to this. Then this is the concept of still the same thing, $6. You and Royston comes out from the battery. Both of you at $6 each. One of you go through here. One of you go through here. Both of you will spend your $6, join back and come back to here, 0. So the voltage, these two will be the same as this one. So answer should be C.
Wait, what? Wait, How,
yes,
how I don't understand the analogy for circuit 2. Like, I don't understand it in general, not just the analogy. Like, why is V equals V3 equals to V4? I just don't get it.
Okay. So the analogy, I go back to the concept of how do you see potential difference. Potential difference is the energy per charge. So like I said, you can imagine each of you as a charge. So every time you go through the battery, it's like EMF, like you gain a certain amount of energy, or let's say we can imagine it as every time you leave home, you get a certain amount of pocket money. So every time you get a certain amount of money, the analogies comes with the thing that, when you come back here, you must be back to 0. So you need to spend everything before you come back. So when you come back, so let's say you and Royston come out of here, you all come over here. Now there's two paths. You can either go through this path or you can go through this path.
Yeah.
So whichever path you use, you can only pass through one of the resistor. You cannot go through here, then come back to here. So it means if you go through here, you use $6, then come back. So the voltage here is 6. If Royston goes through here, he also uses $6 here, so you'll come back to 6. So both will be 6.
Wait, so there's two charges, and if the EMF of the cell is 6 volts, so like both of us will have 6 each, 6 volts each. Then I go through the one path, then the other charge go through the other path. Then is 6.
So it'll be 6 volts, here will be 6 volts.
Oh, okay.
Because the energy per unit charge, each of you will use 6 joules when you pass through here. So Royston also use 6 joules when you pass through here. So then you'll come back to here where it is 0. Yeah.
Okay.
So, resistance here can affect, what does it affect? It affects the current that pass through. So meaning now, let's say this one is high resistance, this one is low resistance. You can imagine as the size of the path. So let's say high resistance means very narrow. Okay, low resistance means very wide. So now I send more of you down here, then more of you will go through the wider path. So the low resistance will have more current, but the amount of energy you use when you pass through here will still be the same as the amount of energy they use to pass through here.
I thought the PD increases if the resistance increases.
The PD increases is the resistance increase. This if it is series. So if we are in series, you come out from here, you have $6. Now I have two resistance. One of them is higher resistance, one of them is lower resistance. You use more energy to go through the high resistance one. Then maybe this you will use 4, then this one you use 2. So this one will have 2 volts, this one will be 4 volts.
Wait, so for the parallel one, it's just that both of them require the same amount of voltage to pass through. It's just that more are likely to go to a lower resistance one.
Right. Yeah. So this is where the analogy does not fully work. It helps to understand certain things, but when you explain it, you push it to the limit, certain things it cannot fully explain anymore.
Oh, okay.
It helps you with a general.
Okay. Yeah, I think I get it. Yeah.
So what about when there's a parallel and a series?
Parallel and series meaning if now let's
Meaning
say
one normal resistor. No, as in like the circuit one, V2 becomes a parallel. Yeah, like that. Would the voltage doesn't split equally, the voltage splits
the voltage here
ratio.
will be the same as the voltage here.
Where and where?
The voltage here will be the same as the voltage here. Yeah.
Okay.
Then you take the voltage here, add up with the voltage here, it will still give you this.
Okay. Can.
Okay.
Thank you.
Okay, any other questions for 2022 last year's O level?
Sure. Can do 37 and 39.
Can.
Just now you said when the current flow in the same direction, right? The force will attract, correct? Yeah, then the answer key says the answer is D. But you see the current flowing the same direction, but the force is
Yeah,
repelling.
same direction. Here all of them current flow opposite direction.
Dummy, right hand rule. Right hand rule.
Yeah.
All of
Wait.
the one on the left is going up, all on the one going on the right is going down. So they are both flowing opposite direction. So it's either C or D already, lah, correct? Because they will move apart, because they are flowing opposite direction.
Oh.
Right? So then you use your right hand grip rule. Then
Okay, never mind.
this one is
Can.
correct. This one is correct. Oh? Yeah.
Okay, I got it. Sorry. Then 39, please.
So over here, I think this one, the direction is wrong, right? Yeah. Okay. 30 what? 39.
Yes, please. (300 Hz). What is the frequency for Q? So over here, one complete wave use up 2 boxes. Now, one complete wave use 2/3 the amount of a box. So the period, so if this one has a period of T, this one will have a period of 2/3 T, correct? So frequency is equals to 1 over T. So why is it
answer
2/3
should be C, because if we take this as one period, right?
Yes.
Then now, when the new wave is 2/3 of the previous one.
Right. Oh. Okay.
Correct. Because now it forms 1.5 in the same amount of time. So the period is 2/3.
Okay.
So the frequency, if frequency is 1 over T, then this one means the frequency will flip 3 over 2 . So 3 over 2 times 300 will give you 450.
So it's just 300 divided by 2/3.
Yeah, you can say that.
Yeah. Oh, okay. Thank you, Mr. Ong.
Yeah. Okay. Okay, so with that, I start to answer some of the questions that's been sent to me. Let me see. Start with Damik. Okay, Damik asked me quite a few questions. Damik, the first question you sent me is from where?
Wait, let me check.
Okay. Oh, never
I
mind.
also
Let me
forget.
just
This
airdrop.
question.
Okay, let me airdrop.
Oh no, this one is my own a friend sent me on.
Can.
Yeah, that I do.
First, so airdrop. Okay. Okay, a diameter and resistance R, another wire has a length that is half as long with twice the diameter. Both wires same material as a result of new wire. Your question is, why is it B? Or why is it D?
And the answer is answer D.
Resistance is twice. First, you see the answer is B or D?
Answer is donkey, D.
Huh? Cannot be.
Actually, wait, let me double check. Maybe I see wrong. Never mind, I think this question can just leave it first. It's fine.
Okay. Okay, first, then I send the other question they send me. What?
This one from
Okay. This one. A circuit contains 3 lamps of different resistance. The switch is closed and all 3 lamps lights up. What will happen to the brightness of the 3 lamps when a bare wire is connected across X, Y? Once it connected across here, so no light lah. Because it was short circuit ma. So lamp 1, first thing is no light already.
Wait, why is it short circuit? I don't get it.
Because now if let's say I send you, Royston, Kendrick, Aaron, all of you, you all come up from here. I have 2 paths for you. One path got resistance, one path no resistance. Which path will you all take?
Victor, where's the here?
You all come out from here, you all come until X. Now I connect another path from X to Y, correct? They say I connect a bare wire from X to Y. So
Wait,
now
Mr.
you
Wong,
all,
are you moving your thing?
oh, how come you all cannot see when I move? Yeah, okay, I don't know why you all cannot see when I'm, okay, maybe I go into edit. Oh, then okay, here can see, yeah. So here you can see, here you can see, okay. So, can imagine I send all of you come out from here, you'll come down.
Okay.
Now there's 2 paths because X and Y is a bare wire that you join across. So X and Y, there's no resistance. Across the lamp got resistance. Then when you come, all of you come here, of course you will all go along here lah. Then it'll be a short circuit in the sense that all of you will skip lamp 1. No
So
one will go through lamp 1.
So
Because
for
the
example,
lamp 1 got resistance, go through resistance bar.
Okay.
So straight away you know that it will be no light for lamp 1. Then now if you skip this also, this means that you can ignore this, then it's just 2, then the overall resistance is now even smaller because now you don't include this. So you have a smaller resistance, then the current will be greater, so it become brighter.
Rachel, can you explain can you please repeat what you said again?
Okay, so now that I'm skipping lamp 1, my effective
Yes.
resistance of the whole circuit now actually drops to just these 2.
Yes.
So if my effective resistance drop, definitely there'll be more current flowing through, it'll be brighter lah.
Oh. Okay, I get it. Okay.
Okay. Yes.
Could you please re-explain what is it though? Like, is it like I don't understand.
Which part? The first one, do you understand? No light.
Like, for me, I thought it's same, but cause the bulb still there, no way.
So the bulb is here, right? So now you imagine I send you, you come all the way to here. Do you want to climb staircase or you want to take the lift? The lift will just bring you straight up.
The lift?
Yeah, so will anyone to climb staircase if everyone can take the lift? No lah, so everyone will take the lift, so no one will go through the lamp. So the lamp will not light up.
Oh, okay, thank you.
Yeah.
So like the bare wire is like something that is easier for the thing to flow lah.
Yeah, because the bare wire, we assume that the bare wire has no resistance lah.
Oh, okay, thank you.
Yep.
Mr. Wong.
Yes.
Is it okay if you can go through kanji paper?
Okay, wait first. I go through those WhatsApp question first. Okay. Oh my God. So
Okay.
your previous question, we take it as there was an error right in the answer.
Yeah.
As in B is correct. Okay, can. Then Zheng Xiang got any question? No, Zheng Xiang don't have. Catherine texts me, but she's not in the chat now. Esther, okay, Esther got a question. Okay, Esther's question. Okay. Why is it B and not C? Oh, Esther, it seems like this particular topic you have issues just on the thermometer one also. Okay, let's take a look. The diagram shows the thermocouple thermometers reading when X and Y are placed in melting ice and the liquid at 35 degrees is at 1.5 millivolts. Or a new reading when X is moved and placed in boiling water instead. So initially, when it's placed in something colder, you have a positive reading. So now I'm going to place in something hotter. Definitely my reading will now go into the negative lah. Okay. And we know that that's actually that kind of explain to you why is it B not C, right? Yeah. I think the calculation you know how to calculate, right? You managed to get 2.79, but how come is it negative and not positive? So X is when X is colder, Y is hotter, is positive. Now, if I continue to put X in something that's colder than 35, I will still get a positive reading because I'll just move along here. But now if my X goes into something hotter, my voltage reading will turn negative. You understand? Is Esther still here? Oh no, Esther is not here. No wonder she's not replying. Okay,
Mr.
never
Wong,
mind. Yes,
how
sorry.
how do you calculate this?
Oh, how to calculate this? Okay. So basically this 35 degrees is 1.5 millivolts. Now I'm going to put it such that it is in boiling water of 100 degrees. So this will be 65 degrees Celsius. So if this is 35 is 1.5, 65 will just be, I'll take 65 times.
Oh, so it's 2.79.
Correct. If you keep the calculator, is it 2.79? 65 times 1.5 over 30.
Oh, so if it's higher
2.7.
temperature to lower temperature, the value will be negative. Lower temperature to higher temperature, value is positive.
There is no, okay, this one is not something to be memorized, but it's something to depend on the context of the question, okay? Because now let's say I keep this as here, and I bring this into something that's 100 degrees Celsius. This will still be positive. But now let's say I bring this to something that's colder than melting ice. Then now I a bit reverse direction already. So now this becomes negative.
Oh, so they replacing X with boiling water lah. So
correct. So now here they replace it to boiling water. Can you imagine? Now instead of moving in this direction, now my temperature now move to the other side. So if it move in this side is positive, now I move in the other side, it should be go into negative.
So for this kind of question, you go by direction, the heat transfer. Direction of the heat, like the direction lah. Okay.
You just look at the question and apply the logic to it because now if it's positive 1.5, I move these two closer in terms of the temperature, it will still be positive. I move it further to each other in terms of temperature, it's still positive. But if I cross any of them to the other side, I cross this to the other side, then it will change sign. Like let's say now it's 35 degrees Celsius. I move it to 1 degree Celsius, it's still positive. But now I move it to 1 degree Celsius to the other side. Does it make sense that it becomes negative? Yeah.
Then wait, can we slowly repeat the 1 degree Celsius again?
So if I slowly decrease the temperature of this liquid to from 35 to 30, 25, blah, 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 until 1, this thing will just keep dropping, but it'll still be positive. Right?
But it's
when the temperature of this liquid from 1 goes into the negative side. Does it make sense that suddenly this voltage will now becomes negative?
When it goes into the negative side, it becomes
Meaning the temperature of the liquid at Y.
Yes.
As it drops, this voltmeter reading will drop, correct?
Yeah. X is still melting ice, right?
Correct. X is still melting ice.
Okay, understand.
So, but we let it drop such that it drops even below this melting ice. from, let's say it's 1 degree Celsius. Now also the liquid here is 1 degree Celsius, it will be positive. But now let's say now it becomes a negative 1 degree Celsius. Then this one must go into the negative.
Negative value.
So
Oh.
similarly, when my melting ice, if I increase the temperature of my melting ice, I increase, this thing will drop because now it becomes narrower and narrower. Make sense?
Understand.
Then it
But it
increase,
still
increase,
remain
increase.
positive.
It still remain positive. But once it crosses 35 degrees Celsius, then this thing will become negative already. And it goes all the way to 100 and so on.
Oh.
So
Okay.
if you go by logical understanding and not memorizing that, what is in what direction is positive or negative, then you become very confused. But you understand how this whole setup works, in the sense that I put it across 2 temperatures if I get a positive value. Now let's say I flip this around, meaning now I take X put here, I take Y put here, I'll get a negative 1.5 millivolts.
Okay. Thank you, Michelle.
Okay. So Esther is not here, so I will direct her to watch this video then. Okay, let me see. Who else asked the question? Let's see. Kedrick asked question. Okay, let me send it over. Yeah, I think it's past 10 minutes. Okay, Kedrick's question. Do another vessel X and Y connected by a short thin pipe tap. X is filled with water of mass M to a depth H, Y is empty. Tap is open, water flow X to Y until depths are equal. How much GPE is lost by the water during the process? Why is the answer B and not C? Wow, this is a very high level question. Okay, but let's see where it's coming from. Okay, how should I explain this?
Make your mic on.
Okay, let me think. How can I explain this? GPE is lost during this process.
Yeah.
Okay. I'm thinking how to attempt to answer this question. Okay,
I tried breaking the H. I tried breaking the H into 4 parts, as in first 1 to 4 different height of 1, 2, 3, and 4 meters. Then the 3 and 4 meters become 1 and 2 meters in the container Y. But that gives me change from 10 GP to 6, which is not 1/4.
So another way to look at this, so I try to think of how to look at this, is that your GPE no, this one should not be H. This one should be no, okay, this is H in terms of the amount of water left.
Yeah.
Okay. So when this is full, where at the highest point, the GPE is at the highest, correct?
Yes.
Then as it drops all the way until it's about half, this one will be half MGH kind of thing, correct?
Yes. Wait, I think your line wrong. Your line should be on the x-axis.
Okay, I'm thinking how to explain, as in, I know the answer is B, but can you see that the energy that is being lost over here is
But
one
when it
quarter.
goes to Y, you still have the energy, what?
When it goes to Y, you
When the
will
height
still.
is half of H for both.
Mm-hmm. Okay, maybe let me see how else I can explain this.
I think you draw two graphs, one for X, one for Y.
Okay, let me see how can I explain this. Okay, how should I say this? Wow. Okay, I also don't know how to explain this offhand. This is not a very typical question. Which school's question is this?
CHIJ, I think.
Wow, okay. Okay. How can I explain this question? Because the energy over here is half mgh. The energy here is half mgh. Energy here is mgh. Okay, this one I don't know how to explain because how I'm looking at this is I'm looking at the concept of integration. Like when it comes to these are things that I learned in university in terms of how I approach this question as an integration of because you can imagine that every point of water here has its own energy.
Yeah. That's why I tried to split into 4 parts, 1, 2, 3, and 4 different heights.
Correct. But the thing is when you split it into that, you are doing a discrete, you are picking a few points. But when
So I
you
should open
you are
to
doing
more points.
integration, you are doing it across from H all the way to 0. You get what I mean? So you are adding up the energy across the whole thing.
So I try using graph instead of units.
Yeah, so just now the one that I drew, it kind of show that, okay, I don't know whether this explanation is correct because if you look at it in this way, when this drop by half, the energy.
I think your gradient wrong. It should be positive gradient because the height increases.
Okay,
so more
be it
area under
positive
graph.
or negative gradient, the main thing over here is that the area, when it goes by half, the area drop by 1/4 and not half. Okay, this one I really offhand, to explain this, I need to go and think of how to explain this, but offhand, the main thing about the area is if you chop this up equally, you can see that actually it's just 4 equal parts lah, but then I only lose 1/4 of it lah.
I understand that part, but when you have to plus y after your minus x, right?
Yeah, but as in, how do I explain this? Okay, this one you let me go and think back again. How can I best explain this? Okay. Yeah. Can. Okay, then let's go back to, I think the class chat has some question. Okay, Royston asked a question. Okay. Royston's question is, A car is accelerating along a level road. Only the front wheels are driven by the engine. Which diagram shows the direction of the frictional force on the front wheels and the direction of frictional force on the rear wheels? Front wheels, rear wheels. Is the answer B, is it?
Yeah, the answer is B, but like I don't understand like why the second wheel will turn in a anti-clockwise direction.
Okay. So the wheel did not turn in a anti-clockwise direction. Okay. The first wheel, why is it F? I think this one we have done a lot of questions like this.
Yeah,
before,
because
right?
like it will oppose the direction of motion, right?
Correct. So okay, yeah, so because the engine is pushing it this way, so push it this way, my friction will go in the other way, correct? So but the rear wheel, there's no engine pushing it. So if you are just being dragged along the whole car because the front wheel is the one that's pushing it, then you're being dragged along, then you will experience the friction in this direction. This one is because got the engine that's pushing it, so the engine is trying to turn in this way, so the friction will end the opposite way. But this one you are just gonna drag by the whole car. So
it just follows it will just oppose the general direction of motion.
Correct. Your typical friction, yeah.
Oh.
Oh, you all find a lot of this kind of not easy question, or these are the ones that I send you all to do, is it?
No, I just remember this question.
Oh, okay, can.
Then can you go through the Chongqing paper?
Okay, first let me see. I still got anyone else ask
Richard, so can you explain again why is the front wheel in this direction?
Oh, this one I thought there's quite a lot of questions that look like this one.
As in the F1, I don't get the F1.
Yeah, the F1 question I thought we do before a lot of times. Let me find and show you. The F1 question is quite a common question. They always like to show one 10-year series gone on. Basically, because when you spin in that direction, then the force will be acting in the other direction. Yeah. Oh,
No,
it's
the another direction one.
Oh, this is a TRS question. Okay, oh, is it last year? Did you all do this last year before? I might get gotten you all to do this before. No, okay, never mind. But regardless, I come back to here. The reason is you can imagine because the wheel is spinning this way. So at this point, it is going this way. So the friction will act in the opposite side.
But for the back, né?
For the back, it's just because there's no engine that's driving the back. So when the whole car moves in this way, then it's just dragged in this way. But the front is like, for example, when your leg dig into your leg push this way, correct? So the friction on your shoe actually is this way.
Oh, so for F1, I need to look at the clockwise rotation.
Yeah.
Mr.
Typical
Wong.
question only show this graph, as in only show this one. Then this one is the other, yeah.
Sorry, Mr. Wong, for F2, the direction of the motion of the tire as F1 is the same one. So shouldn't the direction of F1 and F2 be the same?
No, but because F1 got the engine that is causing it to move, like the engine is the one that is rotating this way. So because it's rotating this way, the friction will go this way. Just like if your leg dig into here, the friction will act in the opposite way. But now let's say you are standing here and someone drags you or push you, then of course your friction will still act in the opposite direction, like this. If you are the one walking, you're the one that dig your leg into the, like when you're trying to walk, you're the one that push your leg backwards, then actually the friction goes forward, then you can grip and then you can walk forward, you can run forward. But then now let's say you are standing there, you hold onto a rope, someone pull you, then the friction will still act in the other direction also. So imagine you are now here, then if someone pulls you like that, then your friction will act like that.
So for this kind of question, we assume that the car is like front wheel drive lah.
No, in
Is
this
it?
case, the question got say that it's front wheel drive.
Oh, my bad. Okay, understand.
Yeah. There, you got say the front wheels are driven by the engine. Yeah.
Oh, so if it's the rear wheel that's driven by the engine, then the force is opposite direction lah. Okay, thank you, Mr. Hall.
Yeah, so this one is a very typical question. Somehow, don't know where is it, but yeah. Okay, never mind. Okay, yeah, so next will be you all have questions from another school paper, correct? Okay, we come to here. Just now quite of you have questions to ask. So who want to go first? First come, first serve.
Cher can go through kanji paper.
Kanji,
Question.
okay, which question?
Kanji, let me check Cher. Question 3.
Kanji question 3.
338 and 39. Thank you.
338 and 39, okay. Let me see. So question 3. A car decelerates at a constant rate from 6 to V for 2 seconds, at a distance of 10. How much longer will it take to come to a rest if it continues to decelerate at the same constant rate? Oh, okay. So this question requires, again, those kind of like graph drawing questions. Let me...
You want power.
So speed. So this speed is time. Is initially 6. Then at 2 seconds, it becomes V. The area here is 10. They ask you what is this. So the area here is 10. This is trapezium. Trapezium formula, half 6 plus V times 2 equals to 10. Yeah. So V equals to 4 lah. This one can follow?
Yeah, I can.
So if V is 4, then 2 seconds it dropped by 2, then of course this one should be 6. So if this is 6, then how much longer? It will be 4 seconds. Is that the answer?
Future, how do you get 6 seconds?
Because 2 seconds, the speed drops by from 6 to 4. For it to drop all the way to 0, if 2 seconds drop from 6 to 4, this means that every second it drop by 1. So 2 seconds drop by 2. So from 6 drop all the way to 0, then it takes 6 seconds to drop. Basically, the deceleration is -1 meter per second square.
Oh.
Okay, because you have A equals to V minus U over 2. V is 4, U is 6, 2, as in the time is 2.
Understand.
So, yeah, -1.
Okay, thank you,
Okay.
Joe. Then can do 38 and
Mr. Wong,
39.
sorry.
Yes.
Mr. Wong, wait. Sorry. Before we go through question 39, right?
Yes.
Can you go through question 37?
Oh, I see. Okay. You want to go through another question first, okay? Okay. So this one, This one we are okay already. Okay, so this one I did it.
Yes, thank you.
Which one first? 29. Is it 29? Joshua?
27.
27. A metal plate is oscillating up and down continuously. In 4 milliseconds, it moves from bottom to the top. The oscillation of the plate causes sound waves to be generated in the surrounding air. Sound travels at a speed of 340. What is the wavelength? So V equals to F lambda, you know V is 340. F, 0.4 millisecond, it moves from bottom to top. So this means that the period is 8 milliseconds. Does that make sense?
Wait, sorry, can you repeat again?
In 4 milliseconds, it moves from bottom to top.
Well, bottom as in the lowest point to the highest point, or what?
Bottom means at the lowest already lah. Top means at the highest, right? You are top in
So it
class means
must
you are
move up
highest in class,
one
right?
time, 2 times lah.
No, so it just move from bottom to top. Just straight away from bottom go all the way to top. It takes 4 milliseconds.
Okay, can.
So one period will be from bottom to top back to bottom, right? So it'll be
Yep.
8 milliseconds. So
Yep.
you know that the period is 8 milliseconds, then you can find the frequency, right? 1 over period. So 1
Yeah.
over 0.008 lah. Then that's the frequency. Then the speed is 340, correct?
Just divide.
So okay. Maybe I will just write it out. Okay, come. Okay, so over this, so divide by this means I can times this lah. Correct. Am I right or not? Frequency is okay. Where's my calculator? Oh, no, I can't do this like that. Okay, so frequency is 1 over 8 times the power of -3. Frequency is 125. So V equals to F lambda 340 divided by 125. Answer is D.
Okay, sure. Thank you. Understand already.
Okay. After 27, who got question?
Question 39. Sorry?
Royston, which question?
The Chongqing paper.
No,
Okay,
I need
I finish
38,
this
39.
first. Okay, Damik, 38, 39.
Yes, please.
Okay, opposite direction means they will repel, correct? So it must be C or D, correct? So if they repel, then their magnetic field will be like C lah. Okay, this one we can go back to your slides. I think go back to your slides.
Mr. Wong, what does that line in between the field represent?
It's also a field line. As in, it's just that it's just straight long.
Oh.
This is under this one, right? Chapter 21. You know, I'm in the wrong document. Okay, slides. when they are opposite there, it looks like this one, with a straight line in the center. You see? So yeah, the answer is C. Okay? Can I me? Okay, that means just now the crunchy one, you still got any question?
39.
39. Okay. Speed of rotation is half. Amplitude will drop, number of peaks will drop. So answer is A lor. Okay, the number of peaks dropping, that one you know, right? Because now you spin lesser, of course, your wave will drop by half lah, right?
No, as in why does the amplitude like change?
Okay, the amplitude change because okay, so we just know that it's half. Okay, I go back to our slides. Okay, so got to do with the factors that affect. Okay, we go back to our concept of Faraday's law. Okay, so okay, because I think I realize whatever I see on my iPad and whatever you see on the screen lags a bit. Okay, anyway, so when an AC generator, okay, how do you increase the magnitude of the current? You increase the number of turns, you use increase frequency of rotation. Okay, so when you increase the frequency of rotation, of course the magnitude will increase. So but then now you reduce the frequency. Now you spin slower, the magnitude also drop.
Also, so the amplitude is the magnitude.
Yeah.
Okay, I understand.
Yeah. So there. So this one is doubling the coils, but when it comes to this there, okay, so this is where if red color is if I spin faster, blue color is I spin slower. So I spin slower, not just the frequency drops, the magnitude of the EMF or the magnitude of the current also drop.
Oh, okay. Understand.
Okay. So we're done with Crunchy. Royston, yours is which one?
Royston.
Chongsheng paper.
Cheng. Which one? Yishun or Min?
Huh? Yishun, I think.
Yishun. Okay, which question?
Alright, let me get my list. Question 7.
Diagram show a position of CG of each standing lamina. Here, lamina is the same weight and of the same material. Which is the most stable? Most stable is the answer A.
Yeah, the answer is A, but why though?
Lower CG, wider baseline.
But why can't it be like D? Because from what it seems, is it like only like from what you see from like connected to the ground or what?
As in, why can't it be D?
I mean, because I also calculate like the area of like the like the amount of area
But
below the circle.
this area is still bigger than this one. Even if this is at 2 cm, this area is bigger than this. This will still be more stable, ma.
Oh, okay.
This
Then,
is higher plus smaller area, so in both ways it's less stable, right?
Oh yeah. Okay, I get it now.
Okay.
Then question 8. Like the next question. I don't understand.
Okay, question 8. A uniform meter rule of mass 0.2 kg is supported by two analytical spring balances. Observation at 20 and 70 cm marks. What is the position at which a 0.1 kg mass must be placed to allow the spring balances to have the same reading? Wow. Okay. Can. This is a not easy question. Wow, they said this kind of question. This one need a lot of calculation. Can I just by guessing no? Cannot. Okay lah, I think I have to calculate. Okay. Then let's calculate. Okay, this question is the typical question where I get you all to do where we take, the moments can be taken about 2 points, correct? Okay. So this one thing we know that is the weight. Okay. This 0.2 kg will be at 50 cm. Okay. So how can I approach this in the simplest way? Okay. Okay. Anyway, from the options here, you already know that I'm going to hang my weight here, right? Because if this is closer to here, just like just now the other question about the beam one, the one that is closer will always have a larger, will pick up more of the weight lah, if you are closer to the CG. So the one that is further away will pick up lesser weight. So of course, to make this the same as this, I'll need to add some weight here so that this one also pick up more weight. So since I already know at this, then I take CG about 70. Okay, so I take CG about here. I mean, I take moments about here. Then there'll be a force up here. So let this be, let's call this A lah. Then this distance that we want to know. Okay, so if it's a clockwise moment. Okay, so if I take moments about, okay, I call this B. B. So clockwise equals to anti-clockwise. So my clockwise will be A times 50 cm. My anti-clockwise will be 0.2 times 20 cm plus...
It shouldn't be A times 30.
30. I take moments about B now.
Oh, okay, sorry.
Yeah. Then this one will be the unknown distance. It will be the 0.1 times this unknown distance lah. Okay. Let's call this, if this is unknown, this unknown is X, then this will be the distance from X to 70 will be 70 minus X lah, right? Yeah. So this will give me, I'm thinking whether there's an easier way to do this.
Must you make like another equation, like using the pivot at A also?
Yeah, seems like it.
Then you have to do simultaneous, right?
Yeah. That's why I was like, wow. Okay, some of this, okay, yeah, some schools, that's how they push their students lah, because the simple questions you can do very fast. Then they give them this kind of questions, or then they will take longer, or then see whether they can do in time long. Yeah. So clockwise Anti-clockwise, I take moments about A. Then my clockwise will now be this one. This one. Okay. So I will have 0.1 times x minus 20 plus 0.2 times 50. Yes.
I think it's easy if you just take the 0.2 as x and then take the distance between A and x, B and x, and then find a solution that makes it equal.
Come again?
Make the 0.2 kg x, then find moment for A and B using x, so it'll be 3x and 2x for A and B, then find a distance that makes the two equal, so it'll be 3.5. 35 cm.
Take moments about where again?
Okay, so 0.2, the 0.2 kg at the 50 cm mark will be x.
So you take moments about here.
No, that's just label it instead of 0.2, doing all the math, it's just x. Then it's just distance from the center of gravity to A and distance from center of gravity to B, so it'll be 3x and 2x because 30 cm and 20 cm.
Oh,
then you just test each distance on. The more reasonable one will be 35 and 45. Then you test 35, 45. 45 will give you
so trial and error lah.
Yeah, sure. Just 2.5x, 2.5x does not give you equal. 1.5x, 3.5x gives you equal. So 35. It's much faster than that.
Yeah, as in if you want to brute force calculate, right? Yeah. As in I was just thinking of that. That one is like easier and faster, right?
Yeah.
Because whatever I'm doing now, I need to take very long.
Take forever.
For the calculation.
Only got like 1 hour for 40 questions.
Okay. Yeah, it seems like that will be the easier way, right? Okay, then should I just erase this whole thing? Okay.
Wait, can I take a picture of this? Like of you're working.
Okay, because I also haven't read finish, but yeah. Okay, but yeah, you can just take a picture, then I'll just try Kedrick's method. Can?
Okay, thank you.
Okay, then let me redo this. Okay, so Kedrick is saying that you use 50 lah. Then we know that this is 30. You know that this is 20. Correct?
Yeah.
So actually, with that, by proportion, if this is 0.2 kg, just by proportion, I know that this will register 0.12 kg. This will register 0.8 kg. Correct?
Yeah.
Because the moment here and the moment here will be the same. So 20 times 0.12, I will get 2.4. 30 times 0.8, I also get 2.4. So this will be what we are registering, right? So now you're trying to say that from here, then where do I place this?
Yeah.
Such that my 0.1, so that they will be the same reading.
Oh, it's 0.1. Yeah, it works too.
So if I have 50 cm, I need to distribute such that my 0.1 will have 0.4 of it going to the one on this side. Then this should be 15 and 35. Is it 45? 45 means 25, 25. Means yeah, this is 50 cm apart. 25, 25. As in, it can't be 45 cm, right? Because 45 cm is equal distance.
Equal, yeah, so I wouldn't change anything.
Yeah. Correct. So the answer must be should be 35 lah, right? Because you try an error. So 35 means this is 15 cm. This is 35 cm also. So it's 15 cm and 35.
Yeah, it's 35.
Right. So then this 0.1 will register to both sides such that this will be 0.1 kg 15, so it will be 0.3 0.03 kg. This will register 0.087 kg. So both will add up to, no, this one is 0.08, sorry, not 0.8. So both will add up to 0.15 kg. Correct. Cadric, this is what I'm trying to say, right?
Yeah, but instead of kg, I just use x. So
Like,
but they're about the same.
Wait, Royston, so far, whatever Cadric was saying and whatever I'm doing, do you roughly follow?
Yeah, I understand already for both.
Yeah. So
yeah.
Yeah, basically this one over here, so if it's, I just try an error loss, so it's 35 cm, this will be 15 cm, 35 cm. Then based on this 15 and 35 cm, my 0.1 kg will distribute such that this 30%, this 70%. So the 30% of the weight will come here, 70% of the weight will come here. So add up, yeah, 0.15 lah, so it's correct. So
Okay, but if if it's like a real open-ended question, I have to go like the first method that you did, right?
Yeah, but I don't think they will come out this kind of question as real open-ended question. This one,
because it's like a bit easier, right?
No, it will take too long, too many marks, and they won't. For this kind, we usually want to do, they will put it in MCQ because structured questions, there's marks allocation lah. So they usually try not to get you to do the same thing for very long just to show your understanding. Yeah.
Okay. Then I have another question. Can you go through a question 23?
Can.
Mr. Wong.
Yes.
Can you go through question 21 first?
And the object O placed in front of plane mirror MN. The students move the eye along X, Y to observe image of O, and then find the points on the line XY where O cannot be seen. So this one, if this one hard copy will be better so that you can really draw it up to scale. Okay, yeah. Okay, wait first, let me screenshot. This is our question during exam, you have this, you draw it to scale. So this is object distance. So plane mirror image, you know that object distance equals the same as image distance. So this will be my image O. So image O, basically then you use your ruler to go and draw this out. Okay. Okay, I'm just sketching. Okay, so based on what you draw, how accurate it is, based on what I draw, only 4 cannot see lah. But what's the correct answer? 21 is B. Oh yeah, so yeah, I anyhow sketch, I also roughly got it, but you should draw it to scale because this one I anyhow sketch, I get it, but some questions you draw quite accurately. They will have certain parts where you just draw not very accurate, their answer is wrong already. Yeah. Okay. Okay, so there is 21. Who is the next one? 23, is it?
Yeah.
Okay.
I don't
23.
understand everything about this.
An object O is placed on a convex and a plane mirror image I. An image I is formed at the same position as object. So frame is correct. Image I is real. Focal length is 10. Distance between the lens and the plane mirror is 2 cm. Between the lens and the plane mirror is 2 cm. Image I remains unchanged. Yeah. Oh, so you don't understand why 1, 2, 3 is correct.
Mr. Ong, why is it real? It's a mirror. Shouldn't a mirror be virtual?
Shouldn't it be virtual? Upright virtual and large.
Okay. So, okay, I see where we are coming from. So, yes, in that case, if you say about the reflection, all this, there is another virtual image that's formed somewhere here. Okay. But based on this one that they say, the image is formed at the same position of the object because there's a reflection. It comes back to here. Okay. So then my image is formed here. Then this is a real image. It's on this side, it will be a real image in this sense. But if it goes into the mirror, then it will be a virtual image. Okay. Because it converges at here and it is a real image. Okay. Then
So the
for-
mirror reflects it and then it converges again.
yeah. So what happens is that it hits on here, it reflects back, then it comes back into here. So the image converges at here. So it's a real, it converge where it is somewhere real. So it is a real image. Then the focal length is 10 because yeah.
Repeat again.
Okay. So the light rays, it converges back at this point. So it is real. Because the one that we learned that it is virtual for magnifying glass is it doesn't converge back at the light actually diverges when you draw it, but then so where does it converge? It converge on the other way where it's already on the virtual side already. But in this case, this one there's really a light ray that passes through. So imagine if there's no mirror here, right? Your light goes out, it can, in this case it's parallel, there will be no they don't really form an image. But now I put a mirror here, the lights get reflected back, and then now it converges back. So if it's able to converge at this real place, so it'll be a real image. Yeah. It's just like, if now I have a lens, I have two rays that come through, and it converge like that, I say that this is a real image, right? So if you ignore that the light came from the object and there was a mirror, you just based on the fact that the light goes through the lens and it converges here, then it's a real image, right? Okay, then the next part, focal length is 10. So we know that when light is parallel to the principal axis, it converges at the focal point. So this is the focal point, then from the focal point to the lens, this will just be 10, so the focal length is 10. Okay, then when this mirror change to 2 cm away from the lens, basically this mirror can move forward, move backward, because this light is traveling straight, so it doesn't really matter how far this mirror is away from the lens. The light will travel straight, hit the mirror, bounce back just along the same path. Then after that, it comes back to the same thing. So the distance between the mirror and the lens actually will not really affect the image in this case, because it's a parallel. The light ray is parallel to the principal axis. Yeah.
If the object moves 2 cm, also won't change the focal point, right?
If the object moves, it does not change the focal point of the lens, but whatever that is being formed here will now change.
Okay.
Because when now if my object is not at somewhere else, when my light goes onto here, how the light will refract will be different story already. You'll not be the same as it is now.
Yeah.
Okay. Okay, 23. Then after that, which question?
Wait, Mr. Ma, I still don't understand. Sorry, can you repeat the third part again? I still don't understand. Because like, if you bring it forward, the eye will remain at that same position.
Yeah, because
Why
this is just traveling parallel to the principal axis. So it doesn't matter how far my mirror is. It's just going to hit and then it's just going to bounce back along the same line.
And then you continue forming at the focal point.
Correct. Because even if my mirror is very far away, the light is just going to travel along the same direction.
Because it's
and
like a
then it's going to come
magnifying
back
lens,
the same
right?
direction. Correct. But if it's not parallel to the principal axis, it goes up or goes down. Then maybe when I move this, then you can change things like.
Oh, okay, I can understand now.
So can you go through question 39 and 40?
Before that, can you also go through question 35?
35, 39, 40.
I need 22.
22.
So you did 21 already, right? Did you?
Yes, I did 21 already.
Okay, then never mind. I'll ask Bryson.
Wait, so after this paper can go to can go the Presbyterian one.
Okay, wait first. So this one,
I pressed
refractive
calculator.
index.
I don't know why I'm wrong.
Okay, refractive index. In this case, we are going from denser to less dense. Is this what you press into your calculator?
Yeah.
Then your
You
answer
use
is what?
radian mode by accident.
No.
So you didn't use radian mode?
I don't think so. Wait, let me try again. Never
22, the answer is D, right? So 2.2.
I think of radian mode. Never mind.
Oh, so it's radian mode lah.
Fine.
Okay.
Wait, so is it okay to go through quickly 21 again?
Can we first? Yeah, 2.24. Yeah, okay. This one, okay. I'm not gonna draw the whole thing out again.
Okay.
Basically, you draw for this kind of question. When you draw first, you draw the image. So I draw the image. It will be equal distance from the mirror lah. So I'll draw it here. Then I'll draw it. From the image. I will draw a line to cut across M. I draw a line that cuts across M. Then I see along here is where they can see the image. Anyone that goes beyond these two edges, they will not be able to see the image. So 4 cannot see the image based on just now what I drew.
Oh, okay then. Thank you.
Then what's the next question?
Question 35.
Question 35. Several turns of insulated wire were wound around a glass tube containing an unmagnetized metal rod. When the wire carries a steady direct current, the rod becomes magnetized shown. Which is or are correct? So based on right hand grip rule, this one will be this way, correct? So this one is not correct lah.
Oh, okay, now I realize. Okay.
Then how you know the direction of the current?
Right hand grid rule.
Cause north south.
Oh,
Your
okay.
thumb is north.
Yeah.
Then your fingers all point down. So your fingers all point down and it goes from Y to X. Okay, then the rest. Okay, so that's all right. 35.
Yeah,
Okay,
that's all.
next.
Thank you.
Just now someone said 39, is it?
Yeah, Aaron said 39 and 40.
Around 39 and 40, yeah, okay.
Yes, please. Just like last two questions and then I can yes.
Then okay, wait first rotated magnetic field between two magnets. Diagram 2 shows the starting position. View at the side. Diagram 3 shows how the voltage between T1 and T2 varies with time, rotated at constant speed. Which one of the points A, B, C, D would represent the voltage induced in a coil when the coil is passing through the position shown in 4. Shown in 4. So, okay, this one let me draw. Okay, so X and Y is when time T goes to 0. So meaning if it goes one round, X goes to Y, then goes back to X, it'll be one full circle, correct? So means one full circle is like that. Okay, so when it is such that it is Y on top, X below, that's half a circle, that'll be here. Yeah. Okay, so when it flips 180, it'll be like that. So then now it moves from this position into this position. So yes, it moves less than 1/4. So the answer should be B lah. If it moves until it is now X is here, Y is here, then it'll be C lah. Does that make sense?
Yeah.
Wait,
So
can you
but
repeat that?
Okay.
Okay.
It was I restart the whole thing. Okay, but Royston, you were to say something.
I was gonna ask is this like an AC or DC thing?
This question, a coil rotated in a magnetic field. So this is AC generator.
Yeah, because the current is induced, right? Then even show the induced EMF.
Yeah.
So it's right hand rule, right?
Yeah, you'll use right hand grid rule for this.
Okay, thank you.
Not right hand grid rule, Fleming's right hand rule.
I mean, yeah, Fleming's right hand rule, but then in this case scenario, you don't really need it, right?
Yeah, in this case scenario, you don't need.
Okay, thank you.
Okay, so Aaron, one full rotation, it brings the X to here, then back to here, correct?
Yes.
So the in-between will be like that. Yeah. So this will be here. This will be here. This is here. This.
Oh, okay. Okay, I got it.
This is here. So this is somewhere here, correct?
Yes.
So the answer is B.
Okay, thank you, Joe.
Okay. Then 40, right?
Yes.
Okay, coil P is connected to a center 0 galvanometer. A second coil Q is placed next to P, connected to a battery, variable resistor R, and a switch S as shown. Which of the graphs best represent the deflection of the galvanometer when the switch is closed for a few seconds and then open? Answer is A lah, is it? Yeah, answer is just A.
But why is it not B?
Why is it not B?
Because
Because
D.
why is it not D?
Yeah. Because why is the deflection like that? Or is it because it only deflects a small bit, then it goes back to its original state?
There's no more change yet in the
okay,
so there's no
So when
not
you close the switch, there's a
just go
change in the magnetic field. So it will suddenly deflect. But then for that 5 seconds after that, or for a few seconds after that, the current just keep flowing normally. there's no change in magnetic field, the deflection goes back to 0. Because there's
Okay,
no
but
change in magnetic field, there's no induced EMF and current over here. Then after that, when I open the switch again, there's a change in the the magnetic field over here. So from got magnetic field becomes no magnetic field. So this one will also experience induced EMF, okay, which cause the deflection. But this deflection will now be in the opposite direction because previously when I turn on the switch, I close the switch, it's as good as I'm bringing a magnet here. So if I deflect in a certain direction, now when I open the switch, means you can imagine as now I suddenly take away the magnet from here, then the current that's produced here will be in the opposite direction already.
yeah, but like I still say like I thought when it deflects, right, then when it goes back, right, there'll be like a slight deflection towards the left side also, or like towards like the other side. So wouldn't the deflection be like a tiny bit below also?
Huh? I don't get you.
Like I thought like whenever a galvanometer like deflects, right, then
Uh-huh.
after that when it goes back, right, there'll be like a slight deflection to the left, like to like the other direction also.
Meaning when it deflects to the right, then when it comes back, it goes back to the left a little bit.
Yeah.
If that really happens, it's just more of the inertia of the needle lah. But by right, it will just go back to 0. Yeah.
So what happens if you were to ask them open-ended, like open-ended, they ask us to draw that, right? Then will we have to show that or don't need?
No, don't need.
Okay, thank you.
Yeah. Aaron,
can you show 39 again?
Sorry, Joe, I didn't catch you.
did I manage to answer?
Yes. Thank you, Joe.
Okay,
Bye.
thank you, Mr. Wong. I'll be going now.
Mr. Wong, I
Bye-bye.
kind of need 29.
Good night,
Okay,
Joe.
Kedrick was about to ask something.
Okay.
Yeah. 39, I didn't catch it.
Sorry?
I didn't
Kedrick
catch
didn't catch 39.
39.
This one, okay, you just wait for the. I'll go and upload the video after this to tomorrow morning or what you can watch or okay?
Okay.
Damik.
29, please. That's it. After that one, sleep ready, Ja.
Then yes. 29. Okay. Which of them describes the force on the nail of each of the material? Oh, this one. Answer is B. Because iron is magnetic, is able to cause the magnetic field of this to go along the iron. So when I do that, it becomes a shield. So there's magnetic shielding. So when there's magnetic shielding, the magnet cannot attract your iron nail.
What do you mean by magnetic shielding?
Magnetic shielding because when I put the iron here, right, when you put a magnetic material near a magnet, it will cause the magnetic field of the magnet to flow along the object.
Oh.
So when it's an iron sheet, it will just flow along here, then the magnetic field cannot really reach the iron nail anymore. So it's what we call a magnetic shielding.
Oh.
Then my copper and aluminium, they are non-magnetic. So they are unable to shield the iron nail, so they can still experience the attraction. I think magnetic shielding, our slides got some graphs to it, or like some diagrams to it that shows that. Let me quickly jump and show you. Magnetic shielding. So we'll put a piece of magnetic material. Okay, because I see that you're still loading. We'll put a piece of magnetic material. Then the magnetic field by right, it just goes along here normally. Now it will go along. The magnetic material will cause the field to flow along it instead. It will concentrate it along itself. So then, yeah, your magnetic field can't move as per normal like that in that case. So, for example, in this case where I have magnets and a piece of cardboard and paper, when it's just a cardboard, it's non-magnetic, the paper clips will just be attracted to a magnet. But if I put a piece of iron in between here, it will do some kind of shielding, then the paper clips will drop.
Okay, I understand. Thank you.
Yeah. Okay. Okay. Any other questions from any other papers?
To the Presbyterian school one.
Oh yeah, yes. Well, just now you said Presbyterian, right? Okay. Which question?
Wait, ah.
Hmm. Yes, Damik. Sorry?
Sorry,
Sorry, you're a bit muffled. I couldn't hear Damik, sorry.
I need Temasek later.
Temasek later. Okay, so Joshua first, Joshua.
Well, maybe try 20.
20 can. D. Okay, 20. Okay, a ray of light is incident on one side. Which path is plotted? Which one is not possible? So this one got to do with the understanding that, when light enters from less dense to denser, it will bend towards the normal. Then when it goes from denser to less dense, it will bend away from the normal. So in this case, here goes in, it bends towards, okay. Here goes out, it bends away, okay. So A is possible. B, it bends towards, okay. Total internal reflection, okay. Because this one, the angle of incidence is quite huge. Then after it comes here, it bends away, can. Okay, B can. C bends towards, bends away, okay. D bends towards, reflects, bends away. D is not possible because over here, if it exits, it should go away from the normal. It shouldn't bend towards. Make sense or not? Denser to less, then it should bend away, not towards. Joshua, did you get this?
Okay, so like in B, does it undergo TIR?
Yeah, here it undergoes TRR.
Then like from less than to denser, it should undergo like refraction, right?
Yeah, from denser to less dense, it will bend away.
Bend away.
Right, denser to less dense is bend away. Okay? Denser to less dense, I bend away. Denser to less dense, I bend away. So denser to less dense, I should bend away, not bend towards. Here they bend towards.
Oh, I see.
Then also doesn't make sense here because here, if here it can here can TIR, then here should also TIR because here the angle of incidence even bigger than here. So if here TIR, here should TIR. So D basically the whole thing is like not very correct. Yeah. Okay. Then yeah, 20. Is there any other question from Presbyterian?
See,
Sorry?
26. 26.
26. Two angle charge field is placed. Angle charge is placed at P. What's the direction of the electric force experienced by this charge? It will be upwards, huh? Is the answer upwards?
Is it because it opposes the current flow?
No lah.
Is it,
No, because these are positive, then
so
this
it
a
must
negative
oppose it,
charge will be opposite charge attract lah. So it just be attracted to
yeah.
here lor. So it just
Cancel.
up. Yeah.
Oh yeah, so you know the prelim, the paper 2, right?
Uh-huh.
think I messed up the DC motor question.
Oh,
Terms of the
okay. Damik waiting to ask question. I move
Okay.
to Damik's question first. Okay. The chit chat we can chit chat again. Okay. Okay, come,
Okay.
Damik, Temasek sec.
Yeah, question 20, please. I don't get it. Oh my gosh. What, Limu?
Question 20. The length of mercury thread in a uniform tube above the bulk of mercury, 20 when melting ice, 170 boiling water, 50 liquid X. This looks like the question that just now.
Isn't this like just math? Like you can draw it out, that melting ice set. Like
No, and this looks like the same question
That's
that
what I
just
did.
now.
I tried to do that. Not sure what I did was because boiling water is 100 degrees Celsius, right? So it's 70 to 20 mm. So 100 degrees Celsius is 50 mm. Then they asked for, I can't remember what temperature. Then I just took that ratio multiplied by that, but I couldn't get the answer.
Okay, wait first. I felt that just now I went through the exact same question with Esther.
Oh.
Is it the same? No, it's not the same. Okay, sorry, it's not the same. Okay, but then can't you think that it's similar? 2 cm,
Yeah, no. So the
70
question
cm.
the question above the one from one note, right? I got that correct, but I don't know why I got this one wrong.
Okay. So this one is the same thing. I have my thermometer at 20, 170. This is 100. I asked for 50. So
Yeah.
this will be 30 cm lah, correct?
So it's
this
100
is 150 cm lah, right?
150.
150 mm.
Okay.
170 to 20, correct?
So
So 30 equals to 100, 30 times 100 over 150, correct?
Yeah.
Then you need to, what is that? That will be A lah, right?
That's A.
20, yeah.
I swear to God, I got D. Wait. Okay, never mind. Maybe my calculator is just a problem.
But
Okay,
correct this.
yeah, I understand.
Yeah.
Okay, I need 21 also.
Oh, okay, 21 just nice here. 1,800 joules of thermal energy supplied to a liquid of mass m in a container. Temperature of the liquid and the container changes by 10 degrees Celsius. When the mass of the liquid is doubled to 2m, 3,000 joules of thermal energy is required to change the temperature of the liquid and the container by 10 degrees Celsius. What is the specific heat capacity of the liquid? Oh, 3,000. So 1,002, 1,002. Okay, first Okay, Q goes to MC, change in theta. They want C equals to Q over M change in theta. So, when the mass doubles, meaning the mass increased by M, this one is 1,002, right? Then M is just M, change is 10 lor. So answer is just B lor.
Wait, why 1,002?
Because when I have M plus the container, M plus
Okay.
container is 1,008. 2M plus container is 3,000.
Okay.
So M will be 1,002 lah.
Wait, I'm so confused.
Okay. 1,800 joules is used to increase M plus container by 10 degrees Celsius.
Ah.
3000 joules is used to raise 2m plus container by 10 degrees Celsius.
Oh.
So if I want to find liquid, which is m,
Oh, just
then,
minus. So it's
yeah, so it's
3000 minus
just
1.
well,
Bro, this is a scam, okay, I understand.
okay,
Okay, boleh. Wait, I think I got like a few, like 2 more. Wait,
can.
I need to check. Sorry, check. Watching retainer. Walao.
Okay.
Question 31, 33, and 36.
31, 33, and 36 are 31. Battery operated fan switched on and lasted 1 hour until battery is flat. During this time, the current remains steady at 0.3. What is the total charge? 0.3 times 60 times 60. Yeah.
So I got 18. Answer key says 1080. Huh?
1 hour is 60 minutes. 1 minute is 60 seconds. So times 60 times 60. Oh.
Oh, I think maybe I never times the other 60.
Yeah.
Okay.
Okay, after 31 is which one?
I think 33. Yeah, 33. The X and Y.
100 cm wire is resistor of 12 ohm is bent into the shape of a circle. X and Y are 2 points on a circle at the opposite each other. What is the effective resistance? So you know, 12 ohms, they bend into a circle. This means here to here is 6, here to here is also 6, right?
Wait, 6?
Because it's a 12 ohm wire, I
Yes.
bend it into a whole circle, so half of it will be 6 ohms. So. Make sense or not? The whole wire is 12 ohms. So if it goes in one whole circle, then from here to here, it will be 6 ohm. Here to here will be another 6 ohm.
Oh, X to Y is 100 cm.
No, X. No, so from here, go one whole round is 100 cm. 100 cm wire bend into the shape of a circle. So this circle is 100 cm. So if this circle is 100 cm, X to Y is 50 cm. So if this is 50 cm, this will be 6 ohm, this will be 6 ohm. So you will take 1 over 6 plus 1 over 6, then you take the inverse.
Okay. Can.
So
I need 36 and 38. That's it.
1 over 6 plus 1 over 6. And I take -1. 3, answer is B. Okay?
Wait, why you take 1 over 6? Oh, parallel.
Yeah, because they are parallel.
Wow. Okay.
Yeah, so it should be B, okay? 3 ohms.
Oh, this question really. Okay, never mind.
Then 30, what? 35.
36 and 38.
36.
Yeah.
This look like just now someone asked this also.
Yeah, the same.
36 and 38, 36K. Electron is moving parallel to a straight current carrying wire. The direction of the conventional current of wire and direction of the motion electron are the same. In which direction is the magnetic force on the electron? So they are moving in the same direction. Means the answer should be D, right?
How do you reduce?
Okay. Because what do we learn about current? What is the direction of flow of current compared to the direction of flow of electron?
Opposite.
So if they say that this electron is flowing same direction as this current, means what is the direction of current by this electron?
C.
It will be moving in C, right? So if you move in C, then I have a current moving here, I have a current moving here. Current moving in opposite direction, they will repel. So the electron will experience a force in the D direction because it's being repelled.
Okay, wait, let me get it. Let me slowly understand. So direction of conversion current in the wire is towards the right. So the electron when the electron goes towards the direction of B, there will be another current in the direction of C.
It's not that there's another current. When the electrons flows towards B, that means the current direction is flowing towards C. Because, okay, there's no such thing as current. I think current was so-called invented before the discovery of electrons, meaning when they thought of electricity, they thought that, okay, never mind, all our current will flow this way. Until by the time they discover electrons, they realize that, oh, in real case, current is just electrons, but actually the flow of electron is the opposite as what we have always thought that current is flowing. But never mind, since we have been talking that current flow in this direction for hundreds of years, let's continue to talk as, it flows this way. So with that, scientists continue to say that current flow in this way, when in fact actually it's actually just electron flowing in the opposite way. So given that in this case the electron is flowing towards B, this means that actually is equivalent to having a current flowing towards C lah.
Okay, so the currents will like so-called like repel each other and
because they are flowing opposite direction.
And then cause the electron to move towards D.
Correct.
Oh, okay.
Because it's repelling, if it's attracting, you'll move towards A. It's repelling, you'll move towards D.
Yeah, makes sense. Oh, okay, last one before I can keep these. Maybe not.
30 what? 38.
Yeah. So how come magnetic field got no force?
A particle has a charge and a mass and is moving in the direction of the field. Which type of field will cause a force to be exerted on the particle? 38.
Oh yeah, just sorry. After this, can do question 8. I forgot to ask you just now.
Can.
Okay, thank you.
So your question is why no magnetic, right?
No, why magnetic like got no force? I thought magnetic field also got force.
Because the charge is moving in the direction of the field. If the charge is moving perpendicular to the direction of the field, then you can do your Fleming's left-hand rule.
Oh.
If your charge is moving the same direction as the field, then yeah, there's no magnetic force because yeah.
But usually magnetic fields will always exert magnetic force, right?
A magnetic field will exert a magnetic force on a charge if the charge is moving perpendicular to it.
Okay.
Yeah. Then question 8, is it?
Yeah. I don't get the resultant force question, John. Royson trying to explain to me, I don't understand.
The answer is A, is it?
Answer key is C.
No, A is A.
Answer key is A.
A reverse. Am I
remember.
looking at the correct answer key?
Give me a sec. Answer key says
A, right?
Wait. Yeah, answer key says A. Sorry, I don't understand why.
The answer key says A, right? Okay. So why? 80 and 60, right? So 80 and 60, the max resultant force I can get is they're in the same direction, correct?
140.
So it's 140. The minimal I can get is opposite direction, correct?
Which is 80 minus 60, 20.
20. So it can get anything from 20 to 140.
Oh, bro. So that's why that's why A is wrong.
Yeah.
Okay.
Anything in between, you just change the angle between the two forces lah.
Yeah.
Correct.
Okay. Yeah. Okay, I understand.
Okay.
Yeah, I understand. Actually,
Okay.
wait, I was just looking at question 4. Can you help me, please?
Can.
For me.
Ticker tape in the laboratory ticks at the rate of 50 times in 1 second. Diagram shows the length of a ticker tape used in measuring the speed of a trolley. What is the average speed of the trolley? 50 times in 1 second.
Yeah, so it's 49 spaces.
First, 50 times in 1 second means between two dots, it'll be 1/50 seconds.
Yes.
Correct? Which is 0 0.02 seconds. Yeah. 1 divided by 50 is 0.02.
Let me check. Give me a sec. 1 divided by 50. Yeah, 0.02. Correct.
Okay. So 0.02, 0.02, 0.02, 0.02, 0.08. Average speed 12, 0.08. This is cm per second. If you want meter per second, 0.12 over 0.08 meter per second. So you key into the calculator. I think it's this one, right?
Which why 12 divided by 0.08? 1, 2, 3, 4. Okay. Oh, bro. Oh yeah. Makes sense.
Makes sense? Yeah.
Okay.
Because 50 times in 1 second means every 0.02 seconds it will tick once, ma. So then in this case, 0.02, 0.02, 0.2, 0.2 takes 4 times. Yeah.
Understand.
Okay.
Mr. Wong, just a general question, right? I was just thinking about it. You know those like pot and pan question, right? I can't remember which question I did just now. It like say like which material to use like as a better like to like conduct the heat to the food. Below is always silver and on top is always black, right?
Material, I thought conduct
I
is
mean
talking about
color,
metal.
the color. Like whether
Uh,
it's shiny or like dark and dull. On top is always dull and below is always shiny, right?
usually, it actually can be both dull.
Wait, the answer is C, right?
For which one?
This one, number 4.
No, D.
Answer is D.
Huh? D? Isn't it 12 divided by 5 times 50?
No, they have 4. Because 1, 2,
Ah.
3, 4.
Oh, okay.
Yeah.
Richard, I sent you a question on WhatsApp. Can we look at that?
Okay. Well, I look at that. Dynamics question. Do you what was the answer for that question?
Which question?
The one about the pen and the conducting.
Oh, it said like the question was like which one conduct the heat most and like keep the food warm on top. Then the answer was on top is silver, below is dull.
Oh, okay. Then yeah. So this one is very specific to the question.
Dynamic, you say on top below. We don't know on top below what.
Yeah, correct. We need to know the exact question. Then I can be more precise.
Why is it C not D?
Hey, this feels like the same thing that just now they were asking. Okay.
Yeah, but I didn't catch it.
Okay, first so you the fusion.
Oh no, 12:30 already.
Yeah.
EMF is at M. So
I
why
was
is
30 minutes
it
to ask this?
C and not D? Is rotating this way. So it is okay. First
Wait, when it's horizontal, there should be no EMF, right? Because
no, horizontal is max.
Oh, horizontal is max.
Horizontal is max.
Wait.
So
horizontal. No, it's flat. Yeah. Max.
Let me see. Then when it's vertical, you'll be at the zero EMF.
Oh, because it's bi-directional and then the moment is 0.
Sorry, what did you say about moments?
Isn't it by moments? When it's straight up, there's 0 moment. Oh no, it's EMF. Sorry, it's EMF. It's EMF.
Yeah, we're talking about moments. I was a bit
Yeah.
confused. Okay, but okay, back to
EMF.
here. Why is it C and not why is it D? Yeah, because the long C is, so this is at here,
Yeah.
and then vertical is at here.
Yeah.
So this is going from horizontal to vertical, so it should be C lah.
Cause D will be going from vertical to horizontal.
Yeah. D is
Ah.
approaching horizontal.
I see. Okay,
C is going away from horizontal, going to vertical. So answer is C.
Yes. Do you set any questions that like are hard, Joe?
Haha.
Oh
hard
no.
objective. But
Okay, let's say hard is like the one you said just now, the one that like impossible to explain. No, right?
no lah, I won't say until those very tedious until you need to like take a lot of steps. and
Oh,
kind of
let's
stuff.
go. Okay, can.
But
Okay,
mostly
there will
it's
be
just
some that
about
will
theory.
definitely be not so straightforward. Like you'll see a lot of questions. Most questions will not just be one formula get answer lah. Like quite a lot of them you notice you might need to combine a few, or like especially those thermal questions. Those MC change in theta one can be quite tedious to
Thermal
calculate.
fine, maybe.
But that one is quite normal lah, that they like they set very tedious calculation questions. But other than that, I won't go and like purposely like
Mr. Wong,
yes.
very sorry, I forgot one more question from Temasek, question 30. Okay, I think I don't care about the Chinese paper question. I cannot find it. I don't care. Tomorrow I just whack. If tomorrow come out, I just whack. I just look at my mother cooking pen and see we can see the color.
Question what?
30, please.
Everyone gone already, yeah.
Yeah.
Just
Hardworking. Oh my goodness me.
The
30.
positive charge metal sphere is placed halfway between previously uncharged metal rods, one of which connect to Earth, which diagram show the charges arranged on the rods. So
it's just C what?
So it's just C.
Yeah, it's only C.
Negative go towards the positive sphere, and then the magnet on the right,
there's no magnet.
No, sure,
It's positive charge.
Isn't that Erding? It's Erding, right?
Yeah, because Earth will make this become like neutral lah. So the charge can flow up or down.
Wait, I thought negative charges go to the Earth.
Yeah. No.
No, the negative charge
only
comes from
negative
Earth.
can move, but the positive, basically the more negative will go up lah, so it becomes negative.
So the difference between this and this is that over here, the when you put a positive charge here, the electrons come to this side. So here becomes negative. Because the electrons move to this side, right? Then here becomes positive. But because this is just within the rod itself, but when I have an Earth over here, right? My Earth can supply this negative charge. So it will not just be here negative, here will be like a bit like neutral lah. So there's more electrons that can go up than as compared to here. So you can
basically the number of protons inside the bar on the right remains the same, but electrons from the Earth flow to the bar because of the positive charge in between.
Yeah.
Oh my goodness. Okay.
Okay.
Mr. Wong, do you think our MCQ will pull up our marks or pull down our marks?
Sure. Do you think MCQ can get 100%?
Very hard to get 100. Like when I was a student, usually school paper I will get like 33 to 36. O-level paper, then I get like 38, 39 lah. But yeah, school paper usually I get like...
Watch us and watch everyone here right now get 100%.
Can.
So I think I can get like 28. I always get like 27, 28. Like my favorite number is around there.
Okay.
I'm going for 37. Hopefully 100.
Can.
Okay, thank you, Mr. Wong.
Okay.
Sorry for making you call me until 4 hours. Wow. Wow.
Oh yeah, it's 4 hours. Yes.
Why? Okay.
World record. My
Okay.
father didn't even come back. Hey, wait, never mind. He overseas. Never mind. Never mind.
Okay. Bye bye.
Okay, bye, Mr.
Bye-bye.
Wong. Thank
Bye-bye.
you.
Bye bye. Thank you.
Bye.
Good night, Joe.
Good night. Bye.